limitation of how far they'll accept in the results of any of these categories. But
yeah, I think Jaren was on the fence for a while before he went down, and that was whether he had decided before or not, who knows. But I think that you and I both have multiple evidences on our side that one little thing, it would make our eyebrows raise, but I don't think it would switch us 100%. So I think in that way we're alike, and a lot of flat Earth and Global are like that. They feel that they have the evidence on their side. So one little piece like this may get some people, but again, I would think it'd be just the same as Antarctica. It would only be a few people either way. So
it's a little bit confusing for me about Jaren, because the guy could explain and talk to people, to talk to globe earthers about stars, the rotations of stars in the south. So for me, it's confusing. You just saw another star. You could explain that to people. You can argue with people when they ask them that, how about stars rotation in the south? So he saw just another star. They call it another star. They consider the sun to be another star among the stars. They saw another star doing the same exact thing as the rest of the stars.
I hear your point on that. At 23.4 degrees south at the Tropic of Capricorn, there's a whole ring of stars, and that's where the sun is at that time of year. So I do hear what you're saying. It's in the same position those stars are, same line of the sky. So why would he be surprised?
Yeah, he knew that there is stars that rotate on the South Pole. So he was still a flat earther. It was something that he could go with. But something changed when he saw another star doing the same exact thing that he already knows. He was baffled. Like, oh, it's not meant to do the same thing as the other stars.
Yeah, but there was that idea that maybe the stars, like in the south, were some kind of like a reflection or due to perspective, and that the sun didn't actually make those circles, but only the stars did, and the sun kept going around the north one. I mean, that was the narrative that people were talking about, at least one of those narratives, and Jeranism was involved in that.
He still didn't verify, even when he went to the South Pole, he didn't verify if there is a reflection or something. What is that thing that he is seeing in the sky? Is it a physical thing, or just light?
Yeah.
He never verified.
Before I hear you on that and the whole Jeranism topic, and I mean, I did mention him, and I would have things that I could say on that, but I just wanted to ask real quick, like on the last part, like Wesley, but do you think if the evidence was like tangible and able to be repeated, it would be a lot stronger and it would, flip either way, as it were, to one side or the other of what the truth is, a much larger proportion? Because just looking at a light in the sky in Antarctica is definitely different than like a tangible measurement of water, for example. Would you agree?
Yeah, but the thing is, and I know you don't agree with this, but several prominent flat earthers made the claim that there was no 24-hour sun in Antarctica, and a lot of that's one of the reasons they followed the Gleason map. I mean, heck, Gleason says there's no sun below the 80th parallel. So if you were a strong believer in the Gleason map and you went down and saw this firsthand, it would probably shake you up. And now I know a lot of people here aren't, and that's fine. But that kind of destroyed his worldview, for lack of a better term. So if we're measuring 12 millimeters over 400 yards, and you think that's going to flip somebody's worldview, you'd have to be. I don't know. I can't answer the question, but like I said, it would make me more skeptical and make me want to look at that more. I don't think it would flip me, but it would definitely, and I don't think it would flip you if it was measured the other way. Because what happens is we all come up with rationalizations for why that happens, and it's an understandable thing, I guess. Is my point.
Well, I hear you. I think it would be definitely strong for evidence for the Earth being a sphere, if the water was measured to be able to be curving like that. Obviously, especially if it was like within 1 millimeter accuracy and you got 11 millimeters, you got 13 or 14, like something pretty darn close. Because I think it was like 12.6. So if you got like 11, 12, 13, 14, anywhere in that range, that would obviously be strong for that. I don't know that I would change my entire view of what the whole Earth is, though, because I mean, there could be like an anomaly. There could be something about the ether that maybe makes water do that. I mean, I would be open to like considering, like, maybe I'm just saying it wouldn't instantly change my entire view. And anyone could probably say they're, where they would be at with certain evidences and whatnot. And I don't think that just measuring the water curving like that would necessarily like change everyone's viewpoint. Who knows? Like, what I would want to see it done, like Nico said, in more areas and with replicated in multiple areas. But I mean, you could technically have like domed water on a flat Earth. I guess technically, like the water could be like a dome, and it could be curving, even though the Earth would actually not be a sphere. So yeah, I mean, technically, there's some side components to all that would have to be considered. But
are you talking about large sections of water and they are curving at the same rate as the globe is curving? I don't think you would find that on the flat Earth. That will make a huge bomb that will be just a globe or half a globe.
Yeah. No, if you're kind of rebutting that, I hear what you're saying. Yeah, I mean, if it was curving to the rate of the globe, how flat could the Earth be if it was curving that much? Yeah, maybe over a small area, you have like a dome of water, but not.
Yeah. You would disagree. Yeah, you wouldn't accept that if it is just a small portion. Just a small section of water, like with that tool you said, like you can measure to 60 meters. Yeah, you would come up with some excuses. You wouldn't accept that as tangible proof. A large section, and if it curves a large section, I'm talking like a huge lake, and you find the same exact curvature as the globe is predicting. Yeah, that will be you just blindly believing the flat Earth and denying the reality of the globe.
You're saying if it was curving at the rate the globe claims and it was shown to be that, you're saying that would be
a huge section of water, yeah, like a huge lake, like kilometers by kilometers. So yeah, if we find that it is curving at that exact rate that the globe is predicting, I can't say that it is electrostatics or electromagnetism or something like that. I can't come up with just an excuse, because it would create a giant hill on that large section. Just imagine if you find that. What can we choose?
Like, yeah, if you tried to make if you had an Earth with the water curving, like if this test could be done and it showed that water was curving at that rate, and it could be done all over the place, all over the world, so that there's no like gravitational anomalies or something funky like that, but it could be done in that way, then the best if all the water was doing that and it could be shown to, then even if you didn't have a sphere, you'd have to have like a hemisphere, you know, which would just be, now you just be on half of a ball Earth, and it wouldn't be a flat Earth at that point at all. So
yeah, correct.
Yeah, I hear you. Well, it's just there's all the debates and discussions. People are in this to like do the mocking, ridiculing. Some people, defend their own viewpoint. Debates. There's a lot of different reasons people are involved. But if we're going to talk about like getting to the truth, and the implications are obviously, I mean, if a bunch of results showed globe, then I guess the only thing the globe guys have to get out of it, I guess, is like the small percentage of flat earthers, I guess they flipped back to the globe. And if that's their passion, or that, because the bulk of the world already believes the globe. So, on that side, it's not really like, I mean, if they like hanging out here, if anything, I guess they would just be ending a discussion or community that they like being in, but maybe some of them would want to do that. Now, but if you, on the other side, to have results that are able to be shown of planar, like tangible physical testing of planar, that would potentially change the whole world. So the implications are dramatically different, just in terms of looking at both of these just 50-50 for the sake of the discussion, and the outcome of having some of these testings that could be more definitive and more exclusive and more able to be verified and replicated, than whatever everybody's already currently either tested themselves or seen out there in the world and come to their viewpoints. Like, and a lot of us that talk about this regularly, it's not like people are flipping left and right. New people come in, they generally are going to probably, in terms of the Earth shape discussion, they're going to generally either be on the fence or kind of one side or the other, maybe concave, a few rare ones, but that's not very common. So, other than that, it's not like there's a ton of flipping of people that have already looked into it and come to some either on the fence or a strong view on either side. But for what this would mean for the scientific paradigm and so on for the non-globe results are obviously completely groundbreaking, pun intended.
Yep. One day with some friends, we were talking and tried to just, you're doing today, try to come with hypothetical experiments or tests that can just help us determine which one it is, flat or globe. So one guy came with an idea just to verify the equator. If the equator is a flat circle on a flat plane, so we will always deviate to the right. If you are going west, you will always deviate toward the right to make that circle around the north.
Yeah, and you know what it would, what the curve. I'm not trying to interject for a long time, but that curvature to the right that you mentioned, if the equator was a circle around the North Pole, around Polaris, that it would be 8 inches per mile squared curvature to the right.
To the right. If it is a ball, there wouldn't be zero curvature toward the right, because it will be a downward curvature for the globe. So it will be 8 inches per mile squared, but downward. So it will create that circumference around the globe. So the guy came with the idea to make sure that those people who are doing this test are in the equator. They are making sure that they are following a straight line. So lasers and some pillars or sticks, and they make sure that they are all in line for very long distance following that equator. And they will see if they follow the west, follow the compass, and at the end they will be able to see if they deviated from that western direction, so the circle around the north. If it is flat, they will just go on a straight line, and they will deviate from that equator because those pillars and those lasers that they will do to make sure that that line that they are following is straight. So the line will continue on a direction straight, and the equator will turn right to make the circle. So at that point, when they travel that long distance, they will check where they are, if they deviated from the equator or not. If they deviated from the equator, it means that they are on flat Earth, and that the equator is a circle around the north.
Yes, that would be for the Gleasons or the azimuthal equidistant type of projection, but not for necessarily the ones that have the two poles, like dual pole. Most of those layouts have a straight equator, and it's a flat Earth.
A straight equator at a certain point, but it deviates for the northern hemisphere toward the right, but for the southern hemisphere, it deviates toward the left, and the straight line will just continue in between toward the infinity.
Right. So that's all I'm saying. Yeah, on a dual pole planar Earth, at least the ones that have been discussed, it would match what the stars do. The stars go straight at the equator, and then clockwise, counterclockwise, you have the two rotations on a planar Earth.
Yeah,
which is the same as the globe, or I mean, not exactly the same, but pretty similar. It's the Gleason's AE map is the only one that has, you know, or it's all concentric circles, and then the equator would be a circle. So you would agree with that? So I'm just saying it wouldn't really rule out. It might rule out Gleason's or globe, but it wouldn't rule out dual pole. You know, if you got the quote unquote globe result of the equator going straight, it could still be a flat Earth, is what I'm saying, with a straight equator. It wouldn't. I'm just saying it wouldn't rule out flat Earth entirely. It would just rule out Gleason's AE map flat Earth.
I see.
But yeah, I mean, if the equator was curving 8 inches to 8 inches per mile squared to the right, that would be very strong for the Gleason's AE map. That would actually debunk the globe pretty much right there, if that could be shown. We've talked about that test. Yeah, it's another one. 8 inches per mile squared curvature to the right of the equator.
If it is a complete circumnavigation, I think that will judge between them all, because it's impossible to if it is a straight line on the double pole map, if it is the equator is straight, it's not coming back to make a circle and come back to its end. So it's straight line. So if you are
do you know, like in the I hear you on that.
So if you are completing the full circle, and it's not, there is no deviation, it means that the Earth is either a globe or a cylinder, or something like that, a diamond, something like that, because you came back to where you started from, following that straight path. I want to call it a straight line because it's the wrong word to use to call a curving line straight. So that straight path that you are following around the globe, to follow the equator, if you are not deviating toward the left or the right, meaning it's not Gleason, and you are coming back to where you started from, completing the circle, which is obviously a circle, that wouldn't be the flat map with the dual poles, because the equator doesn't come to itself.
Yeah, but technically that would be a problem. Like that would falsify the dual pole without some kind of a looping effect or a portal effect, or some people call it Pac-Man, or some kind of a black hole hyperlooping something. I kind of jokingly say I could come up with some word salad to call it something, because I'm not asserting it's the case, so it would be word salad. I would have to just I could come up with probably different words to describe some kind of an effect like that. Meaning that, yeah, I do hear you though. Yeah, I'm just saying if you went straight on a dual pole, and if there was some kind of a looping effect or something, then you could actually come out on the other side. So it wouldn't really falsify that, but it would falsify a dual pole without some effect like that, and it would be stronger for the globe if you could go all the way around, go straight on the equator and come back where you started. Yeah,
I can accept that. That wouldn't be a problem for me, because for someone who will just claim looping effect, yeah, welcome to the real world where a claim without evidence can be dismissed without evidence. So they can't just show me some looping effect where something just go in straight line and come back where it started from. That's nonsense. Yeah, I can take those. I accept those.
Well, to me, it's a stretch. Go ahead.
I don't think you need to use the equator. If you can get the GPS coordinates for one particular latitude, pick any latitude you want. So like the equator is 0, 0, right? Well, if you just compare a short segment of that against the GPS coordinates of whatever latitude you're on, just make a line with your measurement tools and see if you do deviate, like you were saying, to the left or to the right. You don't need to be on the equator.
Unfortunately, there will be a little bit of deviation when you go off the equator. The only place where you can make a circumnavigation following a straight path, the only place is the equator, or another full circumference. Because if you just go off that circumference, you will have to deviate a little bit to the right if you are more toward the North Pole, a little bit to the left if you are more toward the South Pole, and that will work as, like we just said, me and Gio, that will work as it worked on the dual pole map.
Do you understand? Like you were saying just before that you were going to, one of the tools you suggested to use would be a compass, which is reference to the North Pole. And on the map that New Perspective has posted by E1 with the dual pole there, the way the magnetic lines go from north to south, that would be the same. Do you know what I'm saying? I mean, if you're using a compass, you're still going to be fooled.
I understand. I don't really care about the tool that you will use to follow an accurate direction toward west or east. You choose at that point of time when you start the experiment. So you use GPS, you use a compass, you use the stars. You just have to follow west following the equator, or east. The same thing. You follow the line of the equator. You don't deviate from the equator. If there is deviation, if you deviate toward the left or the right, yeah, that will just make everything wrong. But you have to follow that straight path. And if you follow the straight path, if that line, if we see it from the sky and we see that it is a straight line and it is deviating from the equator, that means that it is a flat Earth, and it will pull more to Gleason's map. or something like a Gleason's map that have the equator as a circle around the North Pole. That would be if you deviate from that equator line. And if you are on a flat map like Gleason's map, and the equator is a circle, yeah, you will deviate. If you follow a straight path, you will deviate at the end. If that straight path is long enough, you will find yourself, if it is Gleason's map, you will find yourself at south. You'll find yourself at the South Pole if that straight line you're following is really long enough.
Yeah, that's supposing that the layout of the continents is how they say they are exactly, right? There could be so much slight deviation just every so many sectors that without getting a total bird's eye view.
You really don't care about the layout of the continents. You can just imagine it as just one single ocean. And you are trying to determine that equator, if it is a circle around the North Pole or not, or a straight path.
How do you know when you're on the equator? Do you know that? What's the reference to know that you're exactly on the equator, and how wide is that line before it deviates to the left or to the right?
I swear I never went to the equator. When we will try to do the experiment, I hope you can teach me how I can know that I'm at the equator. But no, I don't know. I can't tell you. If I tell you something, that will be
well,
just
they claim to know. I mean, I've seen those TV programs where they show the water going down a drain in two different directions as you go from one side of the equator to the other. I can't recall. Maybe it's like 100 meters apart or something like that. But
Yeah,
I don't think it's like how close would you have to be before you get any deviation off the equator?
What you saw on TV was basically these people who are charging tourists money to show this, and it doesn't really work.
Yeah, that's just all like, but like besides that exhibition, people actually say that's how it is. But that's science. I mean, that's not me. That's like professors, saying this, not me.
Yeah, you scale the distance of the test with the level of accuracy that you have. If you think that you can't be accurate with a couple meters, yeah, the distance for the test will be just long enough for those couple meters. If it is kilometers, yeah, the distance for your test, that long straight path that you will have to pick to see if there is a deviation toward from the equator or not. If the equator is a circle, yeah, you just you pick it.
It's pretty cool to be able to just follow the sun, like get a drone and just follow the sun and compare the path of the sun, right, with its deviation, because it's got a gyroscope in it, right?
How would you compare that if there is a deviation? If you don't trace a baseline, that you will use to compare it, and those things that you are placing, like those pillars and lasers that you are using to create that long straight line or straight path around the globe. So yeah, that's the thing. But if you are navigating just like that, following the compass, following the gyroscope, you don't know if you are deviating. You're just following the direction. If the compass is telling you to go west, if you turn the direction of your vehicle, you wouldn't know, because it's just 8 inches per mile square. You wouldn't know that you are turning 8 inches per mile square. There is nothing that you have as tools in your things that you are using, plane or ship or car or anything. Nothing that can tell you that, oh, look, you're deviating toward the right.
It could potentially be done. I mean, if you snap a line, snap several lines on the ground, and we've talked about this, that to try to test that. You see what New Perspective posted in the chat? He posted how the sun deviates the opposite way in the south. Like the idea that the sun is making concentric circles around Polaris.
Yeah, for sure.
When it goes south of the equator, it goes the other way. Yeah, like it goes to the left. But you already know that.
So the equator in the dual polar map, like I said, it will continue, but you will have to use something like what you said, teleportation, I don't know, black hole, wormhole, something like that. Because in reality, that equator is not there. The sun is not going through a black hole or wormhole in the dual map. No one is assuming that, and I don't think that New Perspective is assuming that the sun is following the equator and then it goes through a pole and it come back from behind. No, like those GIFs that he sent, yeah, it shows that the sun is deviating toward the right, meaning that it's a circle. It's really going to form a circle around the north. So let's assume that circle, if it is not the equator itself, so let's assume it is Capricorn. it's deviating from the equator by inches, and it's going toward the Capricorn or Cancer. Yeah, those two in that map would be a circle, egg shape.
Yeah, you're right. Necros, you're right. I definitely am not assuming there's a black hole for the sun or any of that kind of Pac-Man thing at all. I don't think you've got your GMs maybe from me, but there's a ton of videos I sent you on this.
Oh yeah, I
It
watched
doesn't have
them
to be
all.
Pac-Man at all. The equator is not the sun equator. Just humor this idea at least before you decide it can't be possible.
I know.
Because it's actually the way I think it actually works, and there's actually something to it if you give it a chance. It goes south for the winter, right? It goes north for the summer. And just think about it. There's no equator. That's the ball thing. The ball says the sun goes on the equator around the ball, right? But in the dual pole model, there's just a celestial equator. That's where the two star fields meet, right through the prime meridian, right? Celestial equator, and the prime meridian is the cross in the middle. It goes from a north to a south pole. All the latitude and longitude lines work. There's nothing about curvature involved, but that seems to be where they might have gotten the curvature idea for the ball, from seeing the magnetic field lines and the electromagnetic field lines of the stars. And those are the lines they actually use to designate the latitude lines in the north and the south. Now, if that's exactly what we see with star trails too. Just look in the chat. I'll put some star trails on there for you. You can see that they converge and diverge. There's two different sets of star trails that you can see in the sky, and it manifests just like an electromagnetic field. Now, that could just be a coincidence, but it's actually a mechanism then that they're using to ride whatever the real satellites are. That's what all the stars and the sun and the moon and all the planets ride on. It's a circuit. It gives it a mechanism.
I already know about that idea, and also I have a nice image, a nice photograph, a panoramic photograph taken between quotations on the equator, taken like time lapse of the stars, and you can see the exact image that Geo sent here in the sky.
Yeah. Now that actually has been the best. If it is that they're converging and diverging, just like all these photographs I just posted show that they're actually going off in different directions. That doesn't work for a globe. It's like the best globe debunk if the southern stars and the northern stars are actually converging and diverging.
Yeah.
And that's what they look like. Anyway, so yeah, the ones that, if you look at the Necros, if you look at the sunset pictures, you can't have the sun setting south of west and then also north of west and have it be going in one direction, in my opinion. I don't know how it would work otherwise. It makes sense. You see it deviating south for the winter.
Yeah. It's an obvious deviation. You can see the tilt. It's really something that you can draw a line and compare them both.
I'm sorry, I lost audio. What'd you say?
I said, yeah, it's obvious deviation that you can see. You can even trace a line, and you can see that that tilt. It's completely the opposite.
And the sun, you can just look up the GPs. Like my friend at E1 that went in the videos I sent you, he was just looking up all the GP data in the nautical omelet. So he just got the sun's GPs and saw it was in one of the quadrants. That's the other thing about this idea, is that you have to have 4 quadrants, which, is how they plot everything out. It has to be in the northwest, northeast, southwest, or southeast for like a coordinate, and it has to be broken up into 4 parts for anything to even make sense. Here's the newest map that I've made, and it actually has all the latitude and longitude lines marked. I've got a better version, better than this even, but this is pretty detailed. See how it's northwest, northeast, southwest, southeast? You have to have all those coordinate points, whether it's a globe or not. That's how they mark the coordinate points. And this looks like a globe, but the sun would actually make kind of a figure 8 if it goes south or north. So it kind of makes that figure 8 cut in the ice. If there's ice still surrounding us, it's just not Antarctica.
Yeah. Yeah, but what makes the sun move in a figure 8 position? What force upon it makes it move like that?
It's an electromagnetic field, a toroidal vortex, a doubled toroidal vortex.
But can't you prove that such a thing even exists? I mean, you're basically theorizing that it moves because of electromagnetism.
Yeah, it's just a theory.
No such phenomenon.
But it actually manifests like an electromagnetic field. So it's a good clue that and the stars are moving consistently in 2 different circles.
Just because it looks like an electromagnetic field doesn't mean that it is.
Diverge, and you can see that happening. So it's not just theory; it's what we observe.
No. You assume that it's an electromagnetic field. You can't prove.
No, that's
an electromagnetic field.
It looks like something doesn't mean it is. There is a charge. Now, the thing is, a lot of flat earthers think that satellites are just on balloons and real satellites don't exist. Well, it seems like they do, and what they're using is this electromagnetic field, and they're deploying these satellites in either the north or the south. And he's saying that basically you have to know the charge of the north or the south when you deploy these satellites to know, because there's a difference in charge. Everything charges up in the south, and then when it charges up enough to go to the north, it jumps over from one toroidal field to another, and that's what makes that analemma flip.
This is a theory. You do understand that for electromagnetism to exist, there needs to be a shit ton of electricity. Where does that electricity come from?
In the sky.
Exactly. That's why
in the sky. On the Earth, it's just a magnetic field. It's a double magnetic field for the longitude lines on the Earth, and then in the sky, it's an electromagnetic field. And it's a double. It's like a double magnetic field to exist,
there needs to be electricity, my man. Where do you get the electricity from?
Electromagnetic field. The theory is that it's an electromagnetic field everything rides on, and that's what it looks like, because we can see an electric field manifest the way the stars look. Then we have the detection of the magnetic field on Earth. Our compasses actually lead you from pole to pole on the Earth, and that can be detected, and that's where the longitude lines come from.
That's based on the electromagnetic field of the Earth, which is very weak. It doesn't
No,
make
the
the Earth
magnetic,
move. You're talking
magnetic,
about
not electromagnetic.
my man.
We don't have an electromagnetic field on Earth.
You're talking about an electromagnetic field that is so strong that it can make a huge ball of gas that is spewing heat move in a figure 8. And also, that electromagnetic field has to change during the entire motion of the sun because your motion of the sun is changing direction.
Yeah, it's
How can
circling
something
within the
change?
toroidal field in this theory. Yeah.
Dude, you understand that an electromagnetic field can't be constant and then making the object move in different directions. The electromagnetic field has to change to make, because it's the Newton laws of moment. Something that changes direction has to have a force that change direction, dude.
So,
Something can circuit within an electromagnetic.
Everybody calm down.
Yeah, new perspective. Our compasses don't wildly shake back and forth, and so why would a sun go in different directions?
Oh, no, you didn't hear me. It's the magnetic field here. I'll put these gifs in. It makes more sense if you look at it this way. Here's where longitude lines come from. This is the magnetic field. It's a doubled magnetic field on the Earth, right? And then on top of that, where all the stars and the sun and the moon, that's where the doubled electromagnetic field is. And that would be then like on top, right? Not on the Earth. We have a magnetic thing that we detect with the compasses on the Earth, and then there's the electromagnetic field that the stars in the sky look like, which actually looks just like the electromagnetic field. I mean, you can think it's just coincidence that it matches our latitude and longitude lines, but otherwise, it's a theory. You can't say it's impossible because actually that's the way it happens.
That theory needs proof, my friend. You can't just say, oh, it looks like it, therefore it is.
I'm not saying that. I'm saying it looks like it, therefore it might be. I'm saying therefore it might be. Therefore it's a way better explanation than balls that aren't even attracted to each other bending space-time. We have bending warping magnetic field lines, and you're calling it space-time. That's where the conflation comes in.
My friend, sir, you can't say that it might be, because I might tell you that there's a flying spaghetti monster that makes the sun move, and my proof is just as strong as yours.
Now, the ball Earth makes claims that are totally a stretch of the imagination.
No, but
right?
That's not
this is actually something that would work.
No, that's not
that's
the point.
My point. This would work. The ball Earth doesn't work at all. Nothing about it works.
My friend, that's not the point. I'm asking you to explain, why does the sun make a figure 8 movement? And you're telling me, oh, it might be magnetism. And then I'm telling you, well, my theory says that it might be a flying spaghetti monster. That he's using his nuclear appendage to move the sun around.
How are you supposed to get up there and know for sure?
You test it.
Yeah, but you don't know either. That's the point. You don't know for sure either. And you're just making it up.
Magnetic field.
I'm making anything up. You haven't watched any of the videos, obviously.
I have, and you have no explanation. You're just making things up, my friend.
No, you're just freaking out because I'm taking the ball away and it's way better.
Quick question. Have you got an original reason for why everything is set in motion in your universal complex?
So, hear me out. If it is a magnetic field or...
No, hold on, that was a question for someone. Hold on, Necros. Who was that question for? The pasta guy?
Mostly for Spaghetti, because he's like challenging the notion that the sun is set in motion, and I just find it rather curious. The solar system, the heliocentric model, it just has the sun set in motion because of what?
I am not, my friend. I'm not defending the heliocentric model. I'm asking him to justify a very specific claim. How is it possible for the sun to change direction? Because if something changes direction, that means that some force is acting upon it to shift in that direction.
That's a double electromagnetic field, which would have a circuit that runs between the two of them. That's an actual mechanism.
What is the thing that changes direction? The sun? Is it actually like a mass, or is it just like an object in the sky that we can't exemplify? We can't give it characteristics, in my opinion. You can just say it's hot.
It is an object that's shifting. It is an object that in his model is shifting movement, and I'm asking him to explain respectfully.
Yeah, toroidal movement. You know what a toroid is? A toroid is a circling, moving force of an electromagnetic field, bro. It gives it a mechanism that actually changes its. And a toroid would make it change direction.
Yes, I understand that, but can you?
Okay, well, it doesn't sound like it. It sounds like you're asking what would make it change direction. What force would do that?
Because you haven't established that it is in fact is a toroid. You haven't established any fact or any proof that it is an electromagnetic field, my friend.
It manifests as such. That's all I'm saying. Like, just don't freak out.
All right, let's just calm down.
It's an example of how it could work.
It could work. My friend, that's the issue. It could work, but it could also be a flying spaghetti monster that makes things move as well.
It's not just as good though. Flying spaghetti monster is ridiculous. This actually could work and make sense.
No, it's not ridiculous because I am employing the same level of you presenting your proof.
Gentlemen,
can you guys chill for a second? Taylor was trying to get in. I think she was. Go ahead, Taylor. You guys talked right over. Taylor, you there?
Taylor. Sorry.
Okay. Can I go?
Why is the premise?
Cool. We got this manifestation of a movement. That's what you referred to it as Pastafarian, right?
Yes.
We see the movement, right? Now
a change. A change of movement, my friend. Not a constant movement. It is a changing movement.
And it follows the trajectory of a toroidal field, right, throughout the sky. So my proposition is why is it so absurd to you that a toroid would have an effect upon the position of the sun versus what the heliocentric model proposes?
Because
the reason for being why it moves in the sky the way it does.
So here's the notion. I reject the premise that just because it looks like a toroid field, that it actually is one. You have to prove without a shadow of a doubt that it actually is one, not only because it looks like one.
So can I reject the premise similarly that the sun appears to be like, you know, in your composition of things?
No. I am not. I'm not defending. No. You are putting the premise. Yeah, but you're putting the premise.
Movement of the Earth.
My friend, you're putting the premise that I have to defend the heliocentric model. That's not what I'm saying.
No,
I'm making the claim, my friend.
We observe the movement. Okay, go ahead.
I'm making the claim that you cannot theorize how something works based on what you think it looks like and based on what forces may exist there. Because if you are
the heliocentric model, then I reject the notion that you think
I'm not claiming the heliocentric. I'm not claiming the heliocentric model, my friend. I'm not claiming it.
No. Okay, pause for a second. We both agree there's an observable movement in exchange between the Earth and the sun, right?
Correct.
We both agree that the two things are moving, right? It's just whether the sun's moving or we're moving.
Correct.
So
this guy's claim that you can't theorize is just stupid. How we entertain?
No, it's not a claim.
If you necessarily observe that they are moving, you got to pick one is moving or the other is moving.
Correct. So both.
Great. So why are you disagreeing with me?
I'm not disagreeing with you. I'm disagreeing with the premise that just because something looks like a toroid field, that it actually is. Just because you theorize.
It's just a theory, bro. It's just a theory, just like your Pastafarian, your pasta monster.
Yeah,
that's a theory. It's not a good theory, but it's a theory. We accept it as a theory. You can't just like restrict people from having theories, bro. That's lame.
Guys, stop. Far out. Okay, I can similarly reject your notion that the reason why the sun moves in the sky is because the Earth is turning, right?
Yes, but the same way, under the same condition, I can propose that there's a flying spaghetti monster moving the sun around, and my theory would weigh as much as his would.
That's not true in my opinion. You can think it weighs as much, but it just doesn't for people that have a brain, bro.
One sec.
But neither do you, because you don't know. You can't disprove that there is an invisible flying spaghetti monster in the sky.
No one Pasta man, I know you're really like fired up. I don't know if you're like working out or like running or something, but we got to go one at a time. Can we try to do that?
Yeah, go ahead.
It's been minutes. I'm trying to get in just to say one single thing.
Yeah, go ahead, my friend. Go ahead.
Was it on topic though? Because these guys are fired up on this. Rixky was about to respond.
It's really on topic. You can use or adopt your own theory, like that flying spaghetti man, just like Newton did with his gravity as a force, and like Einstein did with using gravity as not a force. And he was saying that those planets, without any force introduced on them, they change path and they go on orbital paths, like circles, parts of circles around stars. Circular paths, they changing constantly, all the time, every time changing their path without any introduced force. You agreed with that shit. You love shit. You love that. Now, with another theory of a toroidal field, like the bullshit that Einstein said about the curvature of space-time. Toroidal field. So it's shaped like a toroidal shape, like a donut, and those stars and the sun, among the stars and the wandering stars, it's moving following that path of that toroidal field. Why wouldn't you accept a normal theory, like you accepted obvious things? Didn't Newton just assumed that things wouldn't change their path if no force was introduced? Did he check something moving infinitely in space at that nothing happened, but it changed its path? I swear it happened sometimes. Things changed their path, but it wasn't there to verify.
Look, I
bet you Oscar wasn't like this in school when they were teaching him about balls and gravity. He wasn't questioning the teacher 10,000 times, asking for evidence.
Well, that's not the nature of things, but what's being put forward is we're trying to understand the movement of the sun in the sky, and like the question is like it moves in a toroidal field, so it follows that sort of complex, or it's like set in path as far as like like the heliocentric model is all of these materials are just set into motions like through inertia. They haven't got necessarily a causal claim for why they're set in those paths in the way that they do.
Heart cookies? I'm sorry, my thing's open. I did have something to say though about the sun. I didn't know. Were you finished, Rixkies? I really did.
I was hoping for a sort of a culmination of the idea, like what sets the path of the sun in motion.
Well, let her say her thing about the sun, because that's kind of impossible to know.
Yeah, there's a lot of things that's impossible. Like just like outer space, like they look up into heavens and they say, well, first of all, how did any of this get here? But how did the galaxy still have their spirals? How is it expanding? What is the force that's causing the universe to expand? Think about just from the mainstream model. Like, so what's the force that's causing the sun to move and stuff? Like these are all really good questions that I don't know if we'll ever know, because I believe in the Bible and it says like the mysteries of the heavenly lights, and it says that there are like designated mysteries about them, which is actually really cool. And then in the book of Enoch, it actually says something interesting about the sun, and you can take it or leave it. You don't have to believe it. I'm not saying this is end all be all, but it says the sun rises and sets through specific portals or gates in the heaven. This is very interesting. It's actually in the book of Enoch 7:2 in the Dead Sea Scrolls, which is a 2,000-year-old manuscript of the Old Testament. It had this in it. It says there are 6 portals in the eastern sky through which the sun rises, and 6 corresponding in the west through which it sets. And the portals used vary depending on the season of the year. As the sun rises and sets, the sun's rising and setting positions change throughout the annual cycle. And so it says the sun begins in the 4th portal during the 1st month. And this could just be like that they move through these portals to change, like the analemma through the seasons. They'll like shift over slightly, and that's how the sun's in different positions in the sky between seasons. And I think maybe it's talking about that, but it could also be, referencing setting and rising each day. But that is very interesting. I wonder if like the portal just means like a gate or it's like something like teleportation. I don't know. But it's just something cool to take into account. I who believe in the Bible, like, it is something interesting for me, but I'm not saying that this is end all be all, but it's just something to ponder on. Go ahead.
Hey Taylor, I think it was Yahweh or somebody mentioned the other. No, it was fresh grown flower. I think that was mentioning that the Bible says describes the planets or the sun as circuiting, like it says circuiting in the Bible. Is that, I don't know if you have recollection of that being a word that was used to describe the heavenly bodies, but that's interesting. If the Bible says circuiting,
it says it's on a circuit, and it travels and it goes on its circuit.
What's on a circuit?
In the Quran.
The circuit is just a path.
I've been muted. I'm so sorry. I was trying to respond to you. Yes, it does say the sun runs its circuit. Like each day. But that is very interesting.
But a circuit doesn't mean a circle. Circuit doesn't.
It doesn't necessarily have to be in a circle. Whatever. Yeah. Whatever way it takes, it could be whatever. But it is very interesting how it does describe portals with the sun's movement in general. Like that's pretty interesting.
So, and a lot of the gods are kind of described as like electromagnetic beings or having electromagnetic powers, or qualities, right?
Like angels being stars, like stars being attributed to angel. Maybe there's a star in representation of the angels, or the angels are, that's what's causing the, star through like sonoluminescence in the waters in the heavens above. Who knows? In the biblical model.
Yeah, but explain all the bending light too. It would explain refraction too, the electromagnetic field, or the magnetic field, like affecting the light. That would explain a lot of the refraction stuff too, right?
Yeah, I want to go over that a little bit more later and ask you about that. I've been actually looking into some stuff about the ionosphere affecting even terrestrial light and the binaural changes. But that's my new endeavor, and I hope to do a presentation on refraction. But it takes a lot of background research and time to compose. But anyway, continue about the sun.
I've got a couple recordings saved of you schooling ballers on refraction.
Yeah, they love to mention it, but they don't read that many papers on it. It's very sad.
No, and they probably never read the papers you post every time you talk about it either.
Yeah, and then they'll, I'll post the paper to show one point, and they're like, "Oh, well, does this paper show this other point?" And I'm like, "No, well, here's another paper, to show that point." Yeah. This happened just the other day.
Anything but give any leniency towards you being right. That's for sure.
Yeah, they won't even credit. Like whenever I do back up the statement, they won't even give credit whenever I back up my previous statement. And so we can't make progress. It's a moving
you shouldn't expect that from them. The people that are just trying to shut you up. Those aren't the people to convince, or to talk to about.
Okay, if you're going to invoke something regularly, you need to have a little bit of research on
standard refraction.
There's a lot of updates on terrestrial refraction in particular. I have like 10 papers already in my presentation citing that this quote unquote standard refraction should not be used as like a standard, or it's not reliable whatsoever and shouldn't be like applied in survey.
Yeah, especially with all that margin for error on top of that. They could just go with what do they call it? What do we call it? Super refraction, or what is it? So like there's the maximum.
I've never encountered that in any paper.
Extreme refraction.
Extreme refraction. Yeah, that just gives you all the leeway in the world. Just invoke extreme refraction. So it's nonsense.
Well, to have extreme refraction, you need to have extreme weather conditions matching it. So that you can't just invoke extreme refraction for any observation. Okay, what weather conditions are we going to have that are going to make this refraction? Because you'd have to have out of the ordinary weather. Like, to make things appear taller, you need to have cold air under warm air. But actually, the atmosphere goes the other way in that it has warm air under cold air because hot air lowers density.
Yeah, meaning that all the observations are white swans. All the observations that we are doing are white swans, and now the globers have to find the black swan. Because it's always extreme refraction. Have you ever witnessed the horizon at near the distance where it should be on the globe? Never. So it means that it's always that extreme refraction. That horizon is always multiple distances farther than when it should be on a globe.
Yeah, and it changes
your
with
point
the weather. That's how you know it's not curvature.
Yeah, all the observations are flat Earth observations, and then there's one that you could interpret as possibly being what the globe's saying, but that's the black swan. Really, should be the other way around. Is that what you're saying?
Yeah, because all observations are in our favor, so we have the white swan claim.
Well, they actually like things will move up and down depending on the day and even throughout the day. That's one of the papers I cited, like the mountains getting shorter as the day goes on, And like, so if that's the case, then like, how are we going to assume that things appearing shorter is curvature? And it's so funny, like whenever things appear shorter than they should be, they call it curvature. But whenever they appear higher than it should be, they call it refraction. They're not being consistent all of the way around. But I wasn't trying to take over the conversation for refraction. I wanted y'all to continue on the sun thing if y'all wanted to, but I'm happy to go into the refraction because I'm getting ready to do a presentation on it at some point soon.
If you want to continue, there's no problem. So I just had a point that I wanted to say to New Perspective when he was talking about the toroidal field to the guy, and the guy asked that you need huge amount of electromagnetism and electric potential. Yeah, the source and where you have the highest amount of that electric potential, where you can see it with your own damn eyes. You can see it. Just look at the sky during night in the north or the south, and you will see that electricity, that amount of electricity, ionizing gases. the thing that needs so much potential of electric potential to make ionized gas, to create that plasma, to generate so much energy in the gases and make them split to make a juice of negative materials, which is electrons, and positive materials, which is the ions. You don't have that possibility to see those things if you don't have that much of energy. Where you see that, yeah, coincidence, the north and the south, where you have the center of that toroidal field, from where that field generate and go toward that path, which is the toroidal path, so that donut-shaped path. All those energy coming from this side and going to that side, they go on that toroidal flow, forming that donut shape. You see that every time. It just fool yourself by yourself. No one is doing that for you.
Yeah, there's a lot of things that seem to manifest as such. Like it doesn't. It's not saying that there has to be an electromagnetic field, but like all the things you're saying, and the observation seems to match how an electromagnetic field would manifest, coupled with a magnetic field underneath. You could have a coupled. See, it's an electromagnetic field coupled with a magnetic field, and it just happens to match the way that they draw or the way we use the longitude and latitude lines. You can get from one pole to the other with the longitude. That's what the compass shows. So if you're picking up a detection with the compass, you're going in between the poles. So you mark those lines down, and you're like, now we need to know how to get around the poles and the north and the south to get the other direction. So we'll have a complete directional. I mean, that's possibly where it started. Like they started with that idea, the actual detection of the fields, observing the stars circling in, two different areas, counterclockwise and clockwise. And then they marked everything because those are the consistent things. We have a compass, we have two poles, those are consistent. That's never going to change. So, and that only works on a flat Earth the way it manifests. So it debunks the globe, and it's been there this whole time. And that's a crazy thing. I've been saying this since 2017 with my boy E1. He's been saying, I don't know what the hell's going on with these southern stars. People act like the southern stars don't exist. I don't get it. They're there.
Why I use the aurora borealis when I'm talking about the energy flow and the electromagnetic toroidal field.
Yeah, that's a really good effect right there, the plasma.
Because you can't have ionized gas or plasma like the one that you see in the sky, the aurora borealis. You can't have it only with two things: high potential of electricity, high energy, or heat. Unfortunately, it's South Pole and North Pole. There is no heat there. That amount of heat that you need to create that plasma is not present at those places. They are the coldest places on the Earth. And what else you have left? It's just electricity, meaning that you have ionized gas generated at those places due to what? Electricity, no heat.
Hey, Necros, didn't you make a balloon that you put up in the air, like you did a little test of your own with a detection of ionized collection of energy or something like that?
Yeah, a balloon with a copper wire, a thin copper wire. I just helium in the balloon, and you let the balloon fly, and you will detect. You just use as a discharger the ground itself, and you can eliminate a light bulb. I have also videos from people that are already known for their tests and experiments on YouTube. I have those two.
Oh yeah, there's tons of them. I mean, it's like Tesla, the Warden Tower. I mean, whatever. I mean, this is obviously an electric Earth, right? We're electric. Our salt in our blood, the ocean with the salt in the ocean reacting like an the electric effect of the oceans, and that's why there's waves. It all just fits together.
This guy's fucking brain dead.
The electric explanation. I don't know who said somebody's brain dead, but whoever said that's brain dead for sure. Just saying that. Thoughtful criticism.
I don't know.
Like the Apostle Monster, nothing means anything. It's just as good no matter what. You can't say anything that makes any sense. I'll just say it doesn't make sense, or it makes just as much sense as the thing I like to talk about that makes no sense on purpose.
It's just stupid to deny something that is already measurable. What do you want? You want to measure that the ground is a discharger? That grounding is real? Yeah, just plug yourself into that measuring device that measures the voltage and stand on your plastic shoes. Then you just stand on the ground directly, and you will have those measurements. You can see that grounding is something real. Deny it, and you'll be a stupid fool. You want to measure that there is a positive current of energy that is coming from the sky? And you don't have a container, you globe Earth. So just only God knows from where that positive energy is coming from. We have a container that is already at the same time a second Gaussian plate following the Gaussian law. So we have a complete circuit in our reality. You don't. You want to deny that? We have measurements. Richard Feynman, was it him or someone else who measured that electric potential to 50 kilometers? It was 1.5 million volts. Want to deny that? It's just up to you.
What is the globe explanation for the voltage potential of altitude?
It's just like two Gaussian surfaces. Negative one, which is the one that is below.
But they don't have a Gaussian surface up there. What's their explanation?
Nothing. The spaghetti flying shit that he assumed earlier. He need to use that now.
Can you guys explain to me what the voltage potential of altitude is?
So every something averaged as 100 meters, so 100 volt per meter.
So essentially, you can take a copper wire up into the sky, you can short circuit the voltage potential, and you can show a voltage differential. So it implies then that there is energy coming from the sky constantly,
and it gets
the
stronger
mean
as you get higher, right?
Yeah. Yes.
Get stronger as you get higher. Oh,
Yeah.
right.
Yeah. Well, that's because you're closer to the proximal sort of source point, which is the sky.
The second Gaussian surface, which is the positive one.
But they don't have that in the globe model.
Any link for this?
Absent.
Yeah.
Can someone give me a link?
Yeah.
It's supposed to be cumulative too, right? It's not like you go up 4 meters, it's only 400. It's everything, right?
Yeah, like you have some kind of capacitors in the route. So the energy just is stored somehow in some places like molecules, and sometimes that energy is released as like thunderstorm or something like that.
You're essentially short-circuiting it, the circuit. In order to measure that, you're putting a shint. Is it a shint?
We use systems like that. It's a capacitor. We call them capacitors. It's just
no, but we put in a shunt. Like if you put a shunt in an electrical circuit, you can measure the amount of amps that are coming through it. Very similar complex. If you raise a copper wire up into the sky, you're able to measure a voltage potential. It's working very much like a shunt does in an electrical system.
Here, first video from that guy from the Action Lab channel. So he's a known YouTuber. He tested this.
Yeah, please.
He used
Thank you.
And I will send you another one. This guy from Plasma channel. This channel is nice for people who likes electricity and electric engineering, those things, making things with electricity and playing with plasma and those things. This channel is the best. The guy made wonderful plasma thrusters. So he made thrusters that uses just electricity. Nothing and no movable piece. Nothing moves. Just electricity.
I would like to hear the globe Earth explanation for the voltage potential.
Tina, what uses only electricity? And then what his question? I didn't hear the first part.
The guy I sent a video on the side in the chat that about a guy who made plasma thrusters. Generally thrusters that doesn't have any moving piece.
Wow.
And the two
what were you
videos
saying,
they talk
Risky's?
about. Sorry.
He said he wanted an
Right,
answer to electrical potential.
Yeah, globe doesn't seem to have an explanation for the voltage potential. They've got some sort of like what is it? What's that thing they had to pass through when they went to the moon?
The Van Allen.
So the Van Allen belt seems to be representative of their Gaussian surface at the top end.
So the same energy is coming down from that Van Allen belt.
They literally say there's a plasma sphere. Have y'all heard?
Yep.
Crazy, man.
Isn't that because they can bounce off radio waves off basically what appears to be a ceiling or something solid?
Exactly. And so they're just like accommodating for. They're not. It's not that they like actually went up there and saw it. It's like, oh, well, it must be there because this event's happening. You know, it's crazy. I mean, maybe they did go say that they observed. I don't know, but the ionosphere was discovered the same way, where because the radio waves were bouncing off, that's how they knew there was an ionosphere.
And
crazy is that?
Here, I just sent a video about the incoherent electrostatics. Electrostatic acceleration. So what generated the downward vector mainly?
The Van Allen belt is just completely evaporated in the overall conversation. They don't want to acknowledge anything about the Van Allen belt, but they acknowledge that there's electricity coming from the sky somehow.
And it has a downward vector, right?
The globe explanation is that it's coming from like cosmic rays and the sun.
What's the difference between the plasma sphere and the ionosphere? Because that's how they say the ionosphere is created, right? So what's the difference?
Yeah, they are both nonsense.
And I have one more question. Why is there some sodium layer in the not the ionosphere? It might be around it, but there's a sodium layer also in the upper atmosphere. And guess what? They shine lasers at it. What?
Are you saying that there's salt in the sky?
Yeah. But I don't know if it has chloride, but it has sodium.
Sodium ions.
I don't know either one. Sodium. Whether it's an ion or not, still sodium's up there. What's it doing? How'd they get there? Why?
Salty. It's very salty up there. What's going on?
Almost like water.
Water is above.
I don't understand how you finish the name of certain layers of gases by saying sphere. It's contradicting the definition of gas that says that gases don't take an inherent shape, but they take the shape of their container if they are contained. And now some people are just going with that same exact definition of gas, but still contradict that by saying ionosphere. It's just a bunch of gas and you attribute the sphere shape to it.
Oh, the issue with the idea of a container is that just because you have the idea that gas requires a container is not a proof of the existence of a container.
It is proof.
Just because radio waves bounce off, it doesn't get proof of an ionosphere either.
No, it's like fire investigators. They don't need to see that there were something that started the fire, a spark, something like that. They don't need to find it. They don't need to see it. They know that there is an antecedent for fire, which is the triangle of fire. You have a missing piece, you don't have fire. It's like gas pressure. You have antecedent.
Yes, but fire is easy to see, my friend. It's easy to spot. I mean, you can acknowledge that fire exists because you can see it with your eyes. You're invoking the premise of a giant dome or some kind of container without seeing it. You're basing it off.
Same with you. You're doing a gas. You're doing a contained gas.
Listen,
You're doing a plasmasphere.
You
don't see it.
Fire investigator. I'm not talking about those who will just extinguish the fire. I'm talking about those people who comes after the fire was extinguished. So there is just things that were burned. They don't need to see the fire. They know what is the triangle of fire. They know that there is antecedents for things. Things past.
But we can. I understand, but
you can have that. Like you are telling me, because you didn't see the fire, because you didn't see the thing that burned. Now it's just ash. You didn't see the carpet when it was a carpet, so there was no carpet. There is no carpet.
But my friend, fire exists everywhere. We see fire everywhere. We know how it works.
Exist everywhere. We can't have a void, brother.
Yeah, but we have, my friend,
a void because gas exists.
You cannot compare fire to a phenomenon that has never ever been observed or proven to exist.
No,
we know fire exists.
No, it's never been observed that gas is contained without a container. If you're going to go by your claim, when has that been observed? You're going against obvious.
That's a good point. That's a good point.
Gas is not the phenomenon. Gas is the thing. Breathing is the phenomenon, for example. Inflating a tire is a phenomenon. It's not a natural one, but it's an artificial phenomenon that you can do an action, because phenomenons are actions, not things.
This is a question I have. Gravity,
Taylor,
when does it kick in?
Taylor,
at the upper atmosphere.
You need to understand something that is very important here. I am not defending gravity. I am disputing the idea of a container. Just because I dispute the idea of a container doesn't mean that I'm replacing the idea with a model that you are.
Then how do we have gas?
How are you disputing a container? Gravity is your container within the heliocentric model. That's the reason for the containment.
Well, first of all, I want to make it very clear that you cannot compare fire, that is a phenomenon that is well observed, well seen, and you can create fire at home.
We get it. Yeah,
and you cannot compare that into something that has never ever been seen anywhere on the entire history of humanity. That we don't even understand how it came to be.
Don't drag on your statement any longer.
What do you mean?
So we never see gas hold itself in next to a vacuum ever. That's what we never see. But we see gas being contained.
Actually, that's not actually true, Tyler. We've seen that in a tokamak reactor, which is under a vacuum that has magnetically confined gas inside it.
By the way, you don't
have electrical value.
So
tokamak claims a little bit.
Just bring some random place up.
You don't have just two senses. If you don't see the gas,
is the magnetic field what holds it in here?
You can hear it. Sounds are just the manifestation of the gas itself. Sound, so a sound wave, it's nothing different than the air, which is gas, moving as such a way. So you can feel it, you can hear it, you can feel it in your body. Some deaf people use balloons. They get the balloons, they hold them on their hands, and they feel that music on the concerts that they make for deaf people. They feel the music on the balloon. You don't need to see the thing. So is it because you don't see your brain, you don't have one?
No,
we take a phenomenon and we can apply it to nature.
Sir, that's not the claim. I'm not saying that we can't see air. I'm telling you that a phenomena such as a giant shield or a dome or container has never been observed or proven to exist. We have never ever seen those around anything else ever during the entire history of mankind.
But neither have we seen gas not confined. Okay, like unless you bring a link and show something otherwise.
Taylor, the heliocentric model would claim that gravity holds the gases in, but you reject that premise. So how can
gravity holds gases in? Let me ask you. Can gravity so gravity pulls light gases like helium down to the surface of the earth?
Yeah. Well, that depends on how much gravity there is, doesn't it? Gravity is not a fixed
We're talking about on the earth. Does gravity keep light gases that float to the top of the atmosphere contained? I mean, yeah, aside from a little bleed off here and there, but generally contained. Is helium being contained by our gravity?
Oh, because it's too, according to the heliocentric model and chemistry and physics, no, it's too light of a gas.
It wouldn't be chemistry. So you're saying helium would immediately go off into space?
Yes.
That's not happening.
That's not accurate. Yeah, that's not
helium levels rising in the atmosphere. That's not happening. Helium is actually rising. Helium levels are rising in the upper atmosphere, they claim.
What is the type?
Helium is in the upper atmosphere. It doesn't get stripped off, though. It gets hit by the solar wind, which gives it enough energy to escape Earth's gravity.
Okay, so gravity's holding helium in.
Yeah, that's right.
We should observe helium in a vacuum being pulled down to Earth due to gravity. If that's happening.
Yeah, we do see helium. Like we said before, we had this conversation before, Taylor, but you seem to have forgotten it. And we talked about how a container full of helium is heavier than a container that doesn't have helium in it. That's proof that
in that container of helium, the helium should be falling. If there's no buoyancy,
it is falling.
It should be falling.
It is falling because the container is heavier. When you put it on a scale, it's heavier.
No.
Okay, show me the helium falling in the vacuum,
Taylor.
or any light gases.
Taylor.
She's not talking about that. She's talking about putting
Never
some
said it.
helium, just a little bit of helium, just you create the maximum vacuum that you can create, and leave a little bit of helium inside that vacuum, and see it falling toward the bottom of that vacuum chamber, like a grain of sand being attracted, like your claim, by gravity. You should see that helium being attracted by gravity toward the bottom of that container, leaving you with the perfect vacuum in the top, because all of
Yeah,
those
but I've
gases,
actually looked this
they
up, and
fall.
they don't. But it doesn't seem to fall. They said it did not fall. Like I looked up specifically, does helium attract to the Earth in a vacuum chamber? Does it concentrate near the ground, near the Earth? And they said no. It's all evenly dispersed. So if it's evenly
It wouldn't be
dispersed, then it
evenly
looks like does
dispersed. It would
gravity
have
have
a
an effect
pressure.
on it?
It would have a pressure gradient in the container, which is the only way
You
the
would
container
think.
can gain weight. Yeah, there's a
You would
pressure gradient
think.
in the container, which is why the container weighs more with the helium in it.
You are
If there was
Okay,
no
so show
pressure,
me
if
the
there was no
helium
pressure
fall,
gradient,
helium.
if there was no pressure
Show me the
gradient, the
helium gas
helium.
falling in a vacuum.
You're pressurizing the helium. You're turning the helium into liquid inside that
I know
container.
liquid. That's fine.
No, we're not
I
talking
already know
about a
that.
liquid. Helium is a
Helium
liquid at room
gas should
temperature.
concentrate at the bottom.
You're pressurizing that helium. If you put that helium inside the balloon, I swear you wouldn't measure the balloon heavier than it was.
Yeah, that's only because then because it's
Yeah,
buoyant at that,
yeah.
because of the buoyant force, because it's displacing air that's heavier
Yeah,
than the
because
helium
you
inside
leave
the
the
balloon.
helium, because you leave the helium move a little
And
bit.
it rises up for the same reason why a ping pong ball in a cup, when you fill the cup with water, the ping pong ball rises up for the same reason.
If there's no buoyancy forces, we should see it fall though.
Because the helium on the balloon moves more freely, a little bit more freely than inside a sealed steel container. Yeah, normal.
Yes, and Taylor, we do see it fall, which is the reason why the helium container weighs
I'll
more.
prove it. Whenever I look
You
it
don't,
up,
you
you
don't,
don't see it fall.
you don't think a helium container that has more that has
I'm
pressurized
just saying
helium in
what I
it
looked up.
at room temperature, which is not
that's a non
cryogenic
sequitur.
helium, which is gas helium, you don't think that a container, you don't think that if
I'm
you
not
weigh a container,
hypothesizing. I'm telling you what I saw.
okay, so you don't think that if you go and you rent a container of helium
I don't
and you
care what
weigh
I
it, and
think.
then you,
I like the evidence.
okay, so we can do that test on here. So
Tyler, just because others have seen it and you haven't doesn't mean that it doesn't exist.
Then show it. Show helium that show that helium falls in a vacuum chamber.
Tyler,
Because
answer the
whenever I
question.
looked it up and they saw it not happening.
Tyler,
They
you're not
observed this
answering
not
the
occurring.
question, Tyler. Tyler, I'm asking
My
you
name
a
is not
simple yes or
Tyler.
no answer. Just
My name is
because
not
others
Tyler,
have,
by the way.
okay, ma'am, just because other people have seen it and you haven't, does that mean that it doesn't
No.
exist?
No.
I'm asking for them to show me where, so I can also see it. Do you understand?
Yes, but you're rejecting the evidence because you haven't seen it.
I looked up the evidence, sir. I actually looked into this. What are you talking about?
Yeah.
Where is your evidence? Did anybody else?
You can Google images, ma'am. You can Google
Yeah, I
images
did,
of the
and they
globe
said it
Earth
doesn't
online
fall.
too. You can Google images of the globe Earth too online.
What are you talking, bro? This is such a red herring, bro.
No, it's not, because you are rejecting the premise because you personally haven't seen it, and you're rejecting the premise.
No, I have
because
seen it. I have seen people do it. They've explained that it didn't fall. I'm going off of observations that were done, not a lack of observation. Do you understand?
we could go to the party store and buy a tank full of helium, and then we can weigh the tank with the helium in it. We can open up the valve, let all the helium out, and then we can weigh the tank again and see that the tank will be lighter.
Follow Archimedes' principle, and there you go. Archimedes, by the way, he was there before gravity. So when you have more material, so the density more than of the container is more than that empty container. Yeah, it will sink in the medium more than the empty container. It's just about density of the thing inside its medium, following Archimedes' principle. There is no gravity that you would have to invoke to explain the container that where you add materials. And by the way, that's a thing. Gas, you don't need to see it. It's there. You can see the effect of the thing.
Gas has mass. You will have to trust us on that tip.
Yeah, we believe you.
Did anybody
No, I'm addressing her. I'm not addressing you. I was only addressing her.
No, nobody made any comments like that. Keep up.
The gas has mass. We can move on, right? We agree.
By definition, it's material. It's material.
Yeah, is that what your stunning motion? Is the gas giant and just spinning around?
I think it has electromagnetic mass. That's what I think it has.
So gas has mass.
But what is
I think it has 23. I think it has 23 quantum fields of mass.
I can give them the 100% of mass, but that mass has kinetic energy, what makes that gas move every direction and doesn't have any downward preference following anything. No.
Yeah, gas has a downward preference within Earth's gravitational field. That's just a lie. That's the reason why we have a pressure gradient. That's the actual explanation of why there's a pressure gradient.
No, that's because there is a temperature variance.
It's not the temperature variance. What are you talking about?
There's a downward.
You can put sensors. You can put sensors in a sealed. You can put sensors in a sealed container that is all at the same temperature, and measure the pressure gradient within the sealed container. And you can flip that container upside down, and you'll instantly see your pressure will immediately reorient itself so that the higher pressure will be at the bottom, where a second ago it was at the top on the same sensor.
Yeah. The temperature gradient, the temperature being being responsible for the gradient of gas is incorrect, because there are places on this Earth that is very, very, very cold on ground level, and the oxygen level is the same. And for anyone who has ever been to Mount Everest at base camp, which is about 5 kilometers up into the air, the pressure is much lower, but the temperature is pretty much the same that we have here. So you cannot contribute and say, oh, it's the temperature. That's not correct, sir.
I can demonstrate the temperature variance create a gradient inside the container, seed container, by just showing that there is a container with same pressure from the top and the bottom. But when you
No,
put that
that's not
container
true.
inside, I just have a video. I will share the video.
Yeah,
I'm
but my
just
friend,
talking about that video.
then it would be
But
easy.
you can let
Then
me
it would be
finish the
simple.
shit. You can first let me finish the shit without being triggered. So you put the container inside the bucket filled with water with ice, and you hit the top of that container, and you can see that what it was the same because there is a pressure gauge in the top, and there is another pressure gauge which is in the bottom. There was similar in the beginning, but when you vary the temperature, you can create that pressure gradient where you have higher pressure in the bottom, less pressure in the top.
My friend, you do understand that on this planet, if we can call that, there are different amounts of temperature throughout the entire planet. I am right now in plane of winter. It's minus 10 degrees outside, and the level of oxygen is the same here as it is during the summer when it is plus 30 degrees. The whole notion that pressure gradient is dependent on temperature is entirely false. And let me explain something. One final thing.
It's not a stable thing. That's why the pressure gradient that we have is not really a stable thing. There is winds where you have the higher pressure, so the hot gases flowing to the cold gases. Those are the flight corridors that you have in the sky, the jet streams, the winds, the storms. All those are due to what we just talked about. Yeah.
Do you think there's ever a time? Do you think there's ever a time at the top of Mount Everest where the air pressure is the same as it is at sea level?
At the top of Mount Everest, the same.
Do you think there's ever a time where the temperature or the pressure at the top of Mount Everest is the same at sea level? Since you said that it's a dynamic thing and it changes all the time.
Yeah. There is some point of time where you can have that when there is no.
You do realize, my friend, you do realize that they have weather stations on Mount Everest, right?
Let me tell you when you have no life on the surface, so that can generate heat, then there is no sun in the sky. Yeah, you can have the same exact pressure in everywhere inside the container.
My friend, you do realize that
pressure variance, and the sun is moving between the tropics and all those things. And the sun is setting; it's not sitting there for the whole day. So the sun is rising from a part of that ground, and it's sitting in another side. So the light is attenuating due to that air and the sun when it's going. That's why.
My friend, you're monologuing. We get the point. We get the point, sir. You're monologuing. We get the point. And I'm asking you, do you know that there's weather stations that measure the pressure on Everest? Are you aware of that? And that right now you can go there and download the logs for everyone to see, and the pressure gradient is the same the whole time.
Okay.
I mean, this is just silly. I mean, airplanes would have noticed this a long time ago, right? If the pressure was always jumping around. The altitude, the local altitude adjustment is a very small amount that you can adjust an altimeter for local barometric pressure variation.
Do people all of a sudden suffocate on sea level because there is no oxygen all of a sudden because there's a drop in temperature? No, that doesn't happen.
Why would that?
No, I'm not straw manning.
Be like a steel man of anything. Like
why would that happen if the gas is generated from the surface? It's not pulled by gravity from somewhere else.
How is it generated from the surface?
Plants, trees, sea plants or seaweeds or those things. Everything that recycles that gas.
Yet the highest barometric pressure on Earth has been recorded. Yeah, one of the highest places on Earth
rocks
where
in
the
the bottom of the
barometric
ocean that put off oxygen that are like dispersing oxygen. Look it up. Crazy.
You think that you get oxygen from space and gravity pull it from somewhere? And it's
they're also consuming gas.
This idea that there's a pressure gradient that's created because the gas is being released from the ground or whatever is just ridiculous. Because like I said, you can see the pressure gradient inside a container, and you can flip that container and instantly reorient that pressure gradient, and there's no gas being introduced into that container.
Look at Nyla.
So the highs and lows of the Earth effectively
in reality, I never seen that. Sorry.
So they lead to weather patterns, like all that gusts of winds and all the rest of it, highs and lows across the weather map. That's the reason for all those gusts and blows.
Yeah, you get higher pressure, lower pressure due to the heating on the surface, of course. But that's not what creates it. That's not what's
No, but I know we just had today, right? We had a massive storm fall through, dropped loads of rain, pooling of water everywhere, and now we've got blue skies all of a sudden. So where did the low come from? What's the high? Like where these weather patterns, like this notion that it heats up in one little location over here and it's like a low over there, and these weather flows, it just doesn't make sense.
Yeah, you get that interaction, especially like near the coast, right? Because you have the land that gets hot during the day, and you have the water that stays relatively the same temperature, and then you get the inversion at nighttime because the water has retained a more stable temperature, and the land cools overnight, and the land can get colder than the water can at nighttime, and you get an inversion, right? Where then the wind will shift. You go from onshore to offshore.
The water doesn't have the same temperature. There is always a fluctuation of temperature because of the waters that are coming from different seas.
We're just talking about over the course of the day, the temperature of the Pacific Ocean is pretty steady. Like, how much do you think off the coast of California in the Pacific Ocean, how much do you think the temperature varies over 12 hours?
Yeah, like you have that. Remember the GIF where you can see the movement of the ocean, and because of that refraction, you see the land and the buildings going up and down. I have the GIF. I can share it with you. So yeah, that's because of the temperature variation that's happening during the day, the same day.
Yeah, that's not the temperature variation of the water, though. That's the temperature variation of the air. That's changing the refractive index over the course of the day.
Water isolated? Did you put some foam between the air and the water, and there is no transfer of energy, and entropy doesn't work there anymore?
Oh my gosh, Jake, I had you muted. I'm so sorry. I didn't hear anything you said if you were talking to me ever.
The water is a huge heat sink. Sure, you're going to get some heating on the very surface of the water, a couple of feet on the surface. But over the course of the body of the Pacific Ocean, the temperature is very steady, right? Even the water near the surface is only a few degrees warmer than what it is.
So because the water is constantly evaporating, so you have that humidity. The humidity is coming from the evaporation of water. What humidity itself is just water gas. It's nothing other than water gas. So it's vapor. In other words, in simple words, it's distributed in the air. Sometimes you can't see it. Sometimes you see it and you call it fog. That's the same exact thing. It's always there because water is always constantly evaporating. It's not boiling because its temperature is not hot enough, but it's constantly evaporating. And because of that little variation of temperature during the day, sometimes that evaporation is more and it's harder. The amount of humidity is harder sometimes. And that's
what's the velocity of evaporation?
I don't agree with people that deny the bending of light and light changing its trajectory. So something that they put under the same banner with what they call refraction.
You have to talk for so long about
refraction, but it's there just because of that humidity.
Shorten it up.
What's the velocity of evaporation of stuff evaporating from off the ground or what?
I don't know. That's a deep question.
What's the force of
we can
evaporation?
go and check that. But
what about the dynamic atmosphere keeping that material up?
You can also by just looking at this GIF. Wait, I share the GIF first. Here it is in the text chat. So see that's during the same day. Those up and down, those are not high tides and low tides happening dozens of times during the same day. No.
That's temperature change.
That's temperature change. Thank you. That's humidity. That's water evaporation. Sometimes it's higher.
Not necessarily humidity.
It could be medium change. It doesn't have to be
temperature. So it's little less humidity in the air. All those are gases generated from the surface.
It could be material moving, mixing. Different mediums mixing.
Different mediums, yeah.
You do realize that water vapor behaves differently to air, right? But they both don't have the same properties just because they're gases.
And why you see it sometimes waving? So it's not.
Do you see liquid air around you very often?
I see liquid air.
Yeah, it's an interesting.
There is no liquid air. You're talking about two phases that are not the same. Liquid and air. So the liquid are the second phase of matter, and air.
Yes, I understand that. I'm telling you that there's a difference between water and air, and just because you think both are gases doesn't mean that they both behave the same under the same conditions, my friend.
Yeah, but you asked me if I ever seen liquid air. No, you can't see liquid air.
Yeah, but you see liquid water everywhere.
I would argue that fogs and clouds are liquid air.
What?
I said I would argue that fogs and clouds are an example of something that you could consider liquid air.
No, that's vapor.
Because you've got tiny droplets of water. Clouds and fog is not gas. It's liquid.
Water vapor is a gas. Do you agree with that first?
Yeah, water vapor is a gas and it's not visible.
Water vapor is always composed of 3 molecules, not just one. Gases are always composed. Normal gases are always composed of one single molecule. Water vapor is composed of 3, which is H2O if you didn't know. So water in water is evaporating. It's not separating the so-called molecules that are believed to compose the water. I don't believe that shit.
Nobody is saying that they're separated. You understand that fogs and clouds is not water vapor. It's actual droplets of water. It's tiny droplets of liquid. It's liquid water though. It's not a gas. Vapor is a gas. It's not vapor. It's liquid water.
No, it's not liquid water. Have you ever?
Oh, it could also be ice as well. It doesn't necessarily have to be liquid.
Have you ever heard about liquids and the physics of how liquids behave inside the container? Can you just fill a cup of fog?
But that requires the premise of a container existing, which you can't prove.
It's something that we already have because it is the antecedent.
The air is being contained, or else it would be all going in space, right?
No, it's not.
Something is containing it.
No, it's not.
You say
that the container exists.
Yeah,
just because you don't understand how gases work doesn't mean that there is a container. My friend,
based on the gas laws, they're going to fill the whole space of the container. Gas is your container. Your gravity is your container, right? That's what's containing it.
Just listen.
Yeah, but it's not a container. It's a gradual container. Where the amount of
still
oxygen
container.
is there's a gradient. There's a lesser amount of it the higher up you go.
It's a pseudo container.
Yes. Just
Nico, let me ask you.
because you don't understand
Then why do
gas
you get mad
laws
when I say container?
doesn't mean that you can
You say the same
conclude
thing.
that there's a giant invisible space shield.
And you can't
It's
assume that a
ridiculous.
gravity field, which you don't even know
It's
how it works, is holding in
insane.
gas.
It's cuckoo for Cocoa Puffs.
The problem is that
No one has ever
You sound
seen
like
your
that, though.
shield, my friend. No one has ever
No one
seen
has
it.
seen your gravity. What is gravity? How does gravity work at the atomic level?
Who put it? How thick is it?
Pastafarian, how does gravity work at the atomic level?
Can you tell me how thick it is?
I feel
How does
like
gravity work at the atomic level?
Okay, so you don't know how thick it is. You don't
You have
know.
no
You
clue.
don't know
I
how
asked
big
you
it
that
is.
question first,
You
and
don't
you
know who
responded
put it
with a
there,
question.
but you know
You
it
can't
exists.
answer a
How
question
much
with
do
a
you know
question,
about
sir.
it?
How much do you know about gravity? What
There's
is
tons of
gravity at the
information on
atomic
gravity
level?
online. You just
How does it work
refuse
on
to
the
believe
atomic
it.
level? How does
Yeah, you
gravity
can
work
read
on the
it
atomic
online.
level?
You can read it online, my
How
friend.
does gravity work on the atomic level?
Oh, come on, Taylor. Shit.
Do you want me to tell you what they say online? That they don't know. So you're going to ask us about our container, but yet you don't know about your container and how it works and what it even is. Quit interrupting.
But just because we don't
You
know
don't
the
know about your
cause,
container
and
either,
we
bro.
can't talk about the cause, doesn't mean it's not there. It's why you're not fucking floating. That's the
Same
evidence.
thing about the thing, the container. Doesn't mean it's not there.
No, you can't see no container. You have no proof or no evidence of a container.
No.
The radio wave is bouncing off of something, right?
Left lane.
I propose
You're
that
going to
it's a
say that there's
giant
a
flying
plasma
spaghetti
layer, an
monster
ion layer?
by keeping the molecules at bay, because that theory is as believable as something as a dome, because you have no proof for it.
What is gravity?
So since
What is
you don't
gravity?
have proof for it, then it might as well be a giant flying spaghetti monster keeping their molecules here on Earth.
What is
left lane.
gravity?
So
How do you
the
have
problem,
proof for it in your field? What is it? They don't even know how it works at the atomic level. It's unknown.
the problem with people who doesn't understand antecedents of phenomena, it's like hearing someone, like I said earlier, hearing someone seeing the residue of fire, what happens due to fire. They see ash and they claim that fire can't happen with the triangle of fire. There is no existence of triangle of fire.
Yes, but you can see
doesn't
fire
emit
everywhere, my
oxygen.
friend. It is a well-understood phenomena. We see
can-
fire every
we
day.
can-
You
we
don't
can-
see an invisible shield holding in the gases.
I
That
don't
has
see-
never
I
been
We don't see an
observed.
ion layer either.
You cannot compare fire to a giant invisible shield, my
blind
friend.
people do not
We don't
see
we
fire
don't see a
too.
plasma sphere either.
But blind people do not see fire too, but they do feel it, like they can feel the air. I can
You
hit
can
you
feel
with
a giant invisible
We don't
shield?
see gravity.
I can hit you with the air. I can push your body away and throw it away with just a simple wave of air. That's just
Yes,
air.
the existence of air does not prove a giant shield, my friend.
What you are doing
Doesn't
all
prove
the time
gravity
now is
either.
that you are talking to me. You are using that air. You are vibrating that air.
Yes, my
You are
friend, I
using your
understand how
voice.
sound works.
No,
You don't have to explain it to me.
I swear you don't. If you did understand how sound works, you would understand that air exists. And you can understand how air
Yes,
works.
we both agree that air exists.
And you
I
can
never disputed that.
No. You can understand that you can infer gas laws. Just without seeing air, you can put gas laws. Laws, something that is not just a theory, but a law.
You mean like the law of gravity? You mean like that one? That
What
law?
is gravity?
The
What is
law of
gravity?
Gravity.
How does it work at the atomic level?
So, gravity,
know.
I don't deny gravity.
You're invoking an unknown.
I use gravity. Gravity is called, the precise name is called specific gravity. I never denied gravity. So if
I'm glad we agree on something. That's great.
like Neil deGrasse Tyson, if I'm standing with my friend, if I throw the mic that Neil deGrasse Tyson were holding in his hand, yeah, because the mic is denser than the air, the mic will fall down. But my
What
friend,
is something
because
I
he's
can do on
holding
my own
some
to prove
balloons,
a globe?
it released those 30 kilo balloons filled with some bunch of kilos of helium. They won't fall down. Even
would
if
I
they are
prove-
normally heavier
Okay, you
than
gotta land your plane.
like my microphone.
How do we prove that we're on a globe? Like, how would I go about proving that to myself?
You can.
You can look up into the sky.
I look up into the sky
you
and I
can
say
just,
I'm on a globe.
You can also
I
measure.
look up in the sky and see everything circling around me every single night, year after year, and the same stars.
Okay, ma'am. What makes things move in the sky? What makes them move? Here we go again. What makes them move?
I don't know.
What's making them all move away?
I'm
Dark
asking her,
energy?
what makes them move?
Tell him I don't know.
What makes them move? They're all expanding and moving away from each other from an anomalous force that we have no clue about.
An
called dark
anomalous
energy.
force. Okay, stop there.
That's what y'all invoke.
Yeah, but you're
What
invoking
is the
space
heliocentric
magic.
model? What is
If
your
you invoke
proposition for the
space magic, then I
heliocentric
can
model?
invoke flying spaghetti monster.
Okay, well, then
Why
dark
does it-
energy. I can just
why
say
does-
it's dark energy making it move, right? Just like y'all say it makes everything else in space move.
Whatever those things are, whatever they do in the sky, I don't know what they are. I don't know why they are doing that and how they are doing that. What I know is they are doing that above a flat surface.
Yeah, they don't know why everything's moving.
But then you have zero reason to either shut me down or to deny what I'm saying is wrong if I invoke flying spaghetti monster, because my
Can
theory.
you do Occam's razor?
You can.
No, it's not Occam's razor. It's the invocation of something that you cannot prove.
You
But
can.
that
Okay,
you
cool for
claim
you.
exists.
You're invoking gravity. How do you prove it? What is it?
I can prove that by
You're invoking a
demonstrating.
globe. How do we prove it?
So let him have his theory of the flying spaghetti man.
It's monster, sir. We have a religion.
Monster,
I ask you
monster.
to be respectful
I'm so
to our
sorry.
religion. It's a
I'm so
flying
sorry.
spaghetti monster, my friend.
The
Please.
flying spaghetti monster. So
Thank
what
you.
I can do, I can create gas pressure inside the container. Can you not use a container, but the flying spaghetti monster, if I'm so accurate enough, to create gas pressure without a container. Just the flying spaghetti monster. You have gas pressure, and there is a void. Can you?
Yeah,
I can.
Yeah, we're going
I
against
can
common
create
sense.
gas pressure with the container, and I also can
Exactly.
create gas pressure
We've been
gradient
going
with
against
the
common sense the whole time with the shield. It's
So,
a
so in,
that.
if you
That's
just woke up,
fantastic.
It's not going
okay,
over.
land your plane, unless you're going to give new information, please. Okay, so if we were to wake up on this earth and we were to just see what we see, what would we assume that what we're doing, where we're at? Would we assume we're on a ball flying through space, or would we assume we're on a stationary plane? Which one? Occam's razor. And to prove otherwise, we need some extraordinary evidence that we could be able to test.
Limited to what you could observe, you could deduce that you're at least on a tubular rotating object.
How would we assume that we're rotating if everything looks like it's moving around us?
Because what
well,
it looks like is one thing. What it is a different thing.
That's not a sequitur statement. Can you respond?
It's the same as,
Yes, it is.
It's the same as going down the road and seeing the trees go by and assuming that you're sitting still and all the whole world's passing you by. The universe, saying the entire universe is all moving.
No, we can see a mechanism of motion in a car.
It's absurd.
We can see the car. We're pushing the accelerator. We can make it move faster, slower. We can observe it and manipulate it. We can't do that with the fluid.
Talking about relative motion.
That's completely relevant. I'm going off your example.
Also, the faulty thing that you are comparing linear motion of the car that is going in straight line to angular motion of that same car that is going drifting around.
Irrelevant.
Yeah, a circle. No, it's
What
not
you said was irrelevant.
While the car
We're
is
going off your
around
example and you're
circle,
saying irrelevant. That's crazy.
while the car is going
Yeah,
in
you're going off.
circle,
But you're not. I'm talking about you.
We're manipulating. We're the one giving the energy.
Oh, y'all don't let me talk so I can make my point.
I didn't finish my point first.
There you go. So you watch the sun come up and you trace it across the sky till it sets. Now you got to finish that circle, that half circle you just made, guessing where the sun might be at midnight. And what do you do with? How do you do that and make sense out of it?
The sun's moving through the sky. How do we make sense of that? We say the sun's moving through the sky.
No, I said to complete the
We're
circle
invoking Occam's
after
razor.
sundown.
Am I hypothetical?
Complete the circle after sundown and tell me where the sun is at midnight and make sense of it.
Okay, so we woke up here on Earth. We're observing the sun moving through the sky. Everything's circling overhead, including the sun. So what do we deduce? Everything's moving around us?
So you said it's circling overhead. Trace the sun across the sky and show me that's a circle.
Isn't it moving around the circle of the Earth, as you say?
Ma'am?
You can use the analemma to see the directionality and trajectory of it. Don't quit saying ma'am. Like, you can stop. Don't do that. That's annoying.
Also, her name is Taylor. Just say Taylor.
Just say what you're gonna say. Just say what you're gonna say, dude.
The southern sky and the moon being upside down on the southern hemisphere. There's your example of why the Earth is round.
No, it's not.
Yes, it is. The inversion of the moon is a real thing, my friend.
Is it upside down? Am I seeing the other side of it or something? Because if I turn around, it'll be upside down.
Yeah, like your friend.
It'll be upside down if you watch it from the southern hemisphere. Yes.
Yeah, like your friend seeing the
Who cares?
in the roof of your room as a 9. And
If you say who cares, then it doesn't matter which evidence I prove to you.
So I can say this: the moon's moving, even in your hypothetical, if that was correct, and then I would say the moon, the disk of the moon, which is what I can see, moving over the sky, changing orientation in its vertical plane.
It'll change orientation. It'll be upside down if you're on the southern
I
hemisphere.
wouldn't assume it's a sphere because I can't see the other side. It's tidally locked.
Just let me understand the claim. Is it like you see a 6 in a roof as a 9 compared to your friend seeing it as a 6, and then you claim that the floor underneath your feet, the floor of your room, is spherical? Because
I'm not sure.
You see it from the other side?
Yes. Because
So
you're watching it from upside down. Yes, correct.
Yeah, you have a 6 in the roof or of your room. Now you have a 6.
No, it's a giant 6 in the sky, my friend. It's a giant 6 in the sky.
It's a giant 6 in the roof, filling the
No,
entire
in the sky,
roof
my friend.
of your room. So it's a giant 6 in the roof, of your room. So your friend is in the other side, seeing that 6 as a 9. Do you use that to claim that the floor of your room, because you see it as a 6 and your friend is seeing it as a 9?
My friend, I reject the premise of the room. I reject that premise. Imagine there being a projection in the sky that is a giant 6.
We elevated the same exact 6. We elevated what? 100 meters above your roof?
1,000 kilometers, maybe? 1,000, 2,000?
The same exact thing. You are doing it with your friend.
Hey, do you know? Let me ask you a question. If you're always facing north, whether you're on the southern or the northern hemisphere, is it going to be upside down?
It's going to be one way if you're in the north, and it's going to be upside down if you're in the south.
If I'm always facing north, whether I'm in North Pole or South Pole, will it be upside down?
No, the moon will be as you see it all the time. But if you go to the southern pole,
so you stay facing the same
it'll be
direction.
upside down. No, it'll be upside down if you go to the southern.
North, the moon's north pole will always point towards the celestial north.
Yes, but when you're on the south hemisphere, you will not be seeing the celestial north. You'll be seeing completely different sky, and you'll see the moon upside down.
Because you are looking at the complete opposite direction, like that 6 in the roof, like that 6, 100 kilometers, 100 miles above your head. You, on one side of that 6, you see it as a 6. Still, your friend is seeing it as a 9, upside down. Why? Because you are looking at the opposite direction of your friend. You are facing each other.
If you were to face north while viewing the moon,
he's seeing it.
okay,
But the
so
problem is
if
that
you
the problem is that
were
the
to
roof,
face
the
north
roof
while viewing the moon, okay, which is actually unusual in the northern hemisphere since the moon's generally in the southern sky, you would see the lunar north pole pointing downward, which is the same orientation that the southern hemisphere observers would see if they're facing north as well. You need to understand that point.
no, that's not what they don't.
Yeah.
Because the people that are in
Yes,
the
it
south
is. I
hemisphere
promise
can
you.
see the
Look
moon
it up.
upside down.
Dude, look it up. I don't know what else to
You can
say.
look it up. You can look
I
up that the
did.
Earth is round online.
Okay, this is a non sequitur and a red herring.
No, it's not. Because if you're telling me
Dude,
to look up
address
evidence
the point.
that provides me to be wrong, then I can tell you, okay, but then you can look up online to see the
Address
evidence
the
that you're
point that
saying
if
is
you're
wrong as
always
well.
facing north, the moon's going to be in the same orientation, no matter what pole and hemisphere you're on.
Yeah, and you know what also you're not going to see? You're going to see that
Okay.
the angular size of it will be identical regardless of the time of the
That's
day.
a red herring for sure. That's a red herring for sure.
No, it's not.
Okay,
The angular
so
size
I'm
of the
just
moon
letting
will
you
always
know,
be the
looking
same.
at the moon, if you're facing north, you're going to see the same orientation in the southern hemisphere as the northern hemisphere. Do you understand? So don't make that stupid point again. Just for your
That's
sake.
not true. Australia
Yes, it is.
confirms that they see the moon upside down from the northern hemisphere.
Listen, bro,
Absolutely
I don't know what
beyond
else
any
to say.
shadow
If
of a
you don't
doubt.
believe me, then you can search it on your own. Ask your AI.
Absolutely
If you're
beyond
in the northern
any-
hemisphere or in the southern hemisphere, looking north at the moon, is it going to have the same orientation?
It will.
It's upside
Just
down.
look it up on your AI.
It's upside down.
Dude, ask it. Okay, they say
It's
upside down
down.
because, dude, listen, bro.
It's upside
If you're
down when
in
you're
the
looking at
north
opposite
or
direction.
in the southern hemisphere, as long as you continue facing north, the moon is going to be in the same orientation.
It will never change. Do you think at some point you are looking at the north, you are going backward, and you are going toward south? At some point, the moon will do flip, and it will flip. No, it's
The
just
moon's
because
north.
you, the guy who have feet, you turned away 180 degrees from north. You turn toward the south, and you.
Yes, the flip effect happens because observers in different hemispheres must face opposite directions to see the moon. You understand? And for anybody tagging me, look this up yourself, please. They say, yeah, it flips. That's because you have to face different directions to see it, depending on what hemisphere you're in. That's the only reason they say it flips.
No,
Because you're facing a different direction.
Space gentlemen.
The moon never
A
flips.
sphere, a sphere can be seen from any direction as a disk. A disk seen from different direction will be shown as an ellipse. That excludes the possibility of the moon to be a disk.
I don't know what you're saying. I'm sorry.
You want to say that it is a parabola? Okay.
An ellipse.
Yeah, I
An
understand.
eclipse? Is that what you're saying? An eclipse?
No, ellipse. He said that the circular, perfect circular shape of disk, that if you see it from a side, though, that shape will be oval and more toward a flat line if you're completely at the side of that circle. So he's claiming that the moon can't be a disk. Okay, I don't claim it.
Can it be a bowl? I mean, we're just
claim-
debating whether there's another half. I'm not saying that there's not. I don't even have a problem with there being one. I'm just saying we're using the Occam's razor. I was giving a hypothetical as if we were to wake up here on Earth and just observe. What would we assume? What's the easiest assumption? The most simple and common sense one. If you didn't know, weren't told anything, okay, you would just say you're not moving for sure. Everything seems to be stationary. We see the same stars every year circling overhead. We don't see anything new. Everything's circling overhead around us, around the North polar star. Everything moves around it.
Why do
Polaris.
you say the stars are circling overhead? Why do you say that?
Because if you do a time lapse, you can see them in a circle.
What about the
They're
celestial
curving.
equator and the stars below that?
Well, this would obviously depend on where you're at. But in the celestial equator, if you're pointing absolutely towards the sky and then it doesn't have like a wide angle view, then you might see them going straight. But then they would assume that the stars are just going straight over us every night.
Yeah.
Depending on where you're at, everything seems to, circle over us. Depending on, if you're on the equator, though, it's going to, be going straight. Either way, you still wouldn't deduce that you're on a globe flying through space. It's irrelevant. So how would we determine that? What would we do to come to the conclusion that we are on one flying through space?
And like you said, I go with what you said. There is no possibility to validate it now. If you try, it will give you just a negative result. So no curvature, no ball, no nothing. So what people will do is go in with Occam's razor. The objective reality that we have is that everyone is observing the surface of the Earth as flat, and everyone is observing horizontal horizon, and everyone is observing the flat surface of water, starting from the cup of water to your top.
Not everybody. No.
And
You can't speak for everybody.
In your daily life, do you observe curving water on the surface?
Yes, if you're seeing obstruction, boats going away in the distance, that is due to the curved surface. If
You
you're
can't
seeing
frame it like that.
mountains in the distance that you know are taller than you, but they're below your line of sight, that's due to curvature. So everyone doesn't
And sometimes
experience
they're above your line of
flat.
sight. What happens in the cases where they're not below the line of sight and they're above it? Then what do we deduce?
Well,
Then would we say, oh, it seems like things move in the sky?
But if they're pretty
Depending on
consistent, if you do the same place,
No.
same observation from the same mountaintop to mountaintop, and it's pretty consistent, that's pretty damning.
Yeah, if you do it at the same time of day every day, then it would be,
No,
especially if they
different
move
time of
throughout the
day,
day.
different day of the week, different days of the year. Yeah.
Okay, so show me some mountain observations that are done at midnight or at 3
Yes, he
a.m.
has shown them many times.
No, he doesn't. He's never done one at night, and we see based on peer review papers.
Because he
Stop
didn't do it
interrupting
when it
me!
was
Stop
nighttime. You're
interrupting
going to
me!
reject
Stop interrupting me! Why are you interrupting me? Why are you interrupting me? Why are you interrupting me?
At nighttime when he can't see.
I've already asked him, bro. So stop interrupting me. Okay,
know,
based
bro.
on peer review, bro. Come on, have some integrity. Okay, so we have peer review papers that say mountains consistently get shorter throughout the day. And if you go record them at the same time of day every day, then that's what you would expect, or that's what I would expect. We do see mountains progressively, multiple studies showing they move throughout the day and they consistently have a downward trend as the day goes on, day by day.
And by the way, that's
I've already posted this paper.
I don't know.
I'll post it again.
And
So you don't know about the paper I'm talking about? What if I showed it to you? Would you concede?
So Leftlane,
How much does that change, Tyler?
So there's multiple papers. There's one of them that just shows that mountains progressively get shorter throughout the day. There's another one that does mountain peak to mountain peak in the Swiss Alps, and they saw that the vertical displacement was 31 centimeters over 2 kilometers, which happens to be like within 1 centimeter of what curvature is present over 2 kilometers. Just ironically, but that's a side note.
2 kilometers is nothing.
It doesn't matter. You asked how much they changed. I'm giving you peer-reviewed studies that looked at the vertical displacement.
Yeah, I mean, yes, atmospheric refraction can do that, but does it compensate for like long distance of the measurements?
What?
Does it match what is expected on a curved Earth when you do these measurements?
Yeah, in that case.
Distances? So
I
refraction.
don't know. The only peer-reviewed papers I can see actually did 2 kilometers. Now the people, so we know that they change throughout the day. They say it's due to temperature changes. So then we need to say, okay, over longer distances, is that compensated for? Well, we need to test that. But when we do, we need to account for the vertical temperature change.
Yeah,
Just
I'm aware
like
of that.
this day is
That's my
affecting these
question.
things.
Yeah, yeah, and we have
So
sort of
show
an
me
idea.
them doing that,
There is
accounting for the vertical temperature gradient.
So if one do that, then one can correct for atmospheric effects. Yes.
We'd have to see what they get.
Yes, we do, don't we?
Yep.
And do you think
Yeah, we
that's
sure
been
do.
done? Do you find any
Well,
papers
whenever
where
I
that's been
accounted for the vertical temperature gradient, it was closer to the FE prediction.
always, every single time?
I repeated it 3 times. That's all I've done so far.
Where did you do your measurements?
At the Bonneville Salt Flats.
Yeah, close to the ground. Close to the ground. Why not?
Wait, close to the ground. It doesn't matter if it's close to the ground. The
Yes,
only reason they say that that's a bad thing is because the temperature gradient is so steep. But if you account for the temperature gradient, then that doesn't matter.
So yeah, but why do you always do the discussion here was if you do from mountain peak to mountain peak at higher altitude,
Well,
usually
either way,
the effects of the refraction is less than close to the ground. You agree with that? Yes.
I guess so, but you need to still account for it because we see a vertical displacement of the same amount of present as Earth's curve. And this is a daily cycle. This is something repeatable and observable. So then you just have to account for it.
Yeah, but
Whenever I accounted for it, it didn't match the globe prediction.
No, but you did it on salt flats close to
Doesn't matter.
surface. Yes,
the whole
it does.
thing about
Of course,
so
it does.
this is the whole thing. Let me tell you, it's accounting for refraction. That's why they say there's more refraction near the surface. However, if you account for it, then it doesn't matter where you're at.
For observations, if you plug them into Walter Bislin's model, you always have to slide the refraction slider to the maximum.
No, you don't.
No, you always. I swear.
No, not always.
Many times, hundreds of
Well,
times.
I'm just telling you what I've observed and what I've read in peer review papers, which I
Did
believe
you use like a
credit.
Did you use like a theodolite? What did you use to do the measurements? How
Yes,
did you do
I did use a theodolite.
And over what distance?
I did it over 1 mile.
1 mile, and you were absolutely sure that the elevation of the surface you were on was.
Yes, I looked at survey places that were survey graded and are doing the LiDAR scans to look at the. Yeah, it's like one of the flattest places on Earth, and I looked for the flattest part of it. It only had within the whole thing a deviation. I'm still talking. It only had within the whole thing a deviation of no more than 8 inches. So absolutely, yes, I did look to make sure it was surveyed and properly analyzed to assume it's it's flat within a reasonable standard.
Okay, so
definitely not an 8-inch drop over a mile.
You did this over 2 miles?
I did over 1.
You did 1, and what was your result?
My results, accounting for the temperature gradient, matched closer to the FE prediction. My results overall did see a drop over distance. However, what many people don't do is they don't properly account for refraction, which we know that makes things change throughout the day. But when I accounted for it properly, as the Journal of Surveying and Engineering says to do, then it matched the FE predictions closer.
Yeah, but have you checked every single paper regarding this? Because I was reading up a paper recently about construction of a dam, where they did very extensive tests of the effects of refraction. And when they did that, those measurements matched the globe and not the flat. So it's just
And they accounted for the vertical temperature gradient?
Yes, they did.
Okay, well, send me the link. I'll check it out.
Yeah, I can see if I can find it. I'm out to walk my dog for the time being. But
Yeah, definitely find it if you're going to bring it up.
but all this started with, I don't know who said it, but like ships going over the horizon.
I can cite everything I'm referencing.
Sunsets, sunrises, stars dropping below the horizon. How do you explain that on a flat?
Are you scattergunning right now?
No, that's what this started with.
What are you talking about?
Well, this started.
They actually found a paper from the Royal Society when it was going over for refraction, and the ship's going over the horizon, and they assumed that was from refraction. So in the 1800s, the Royal Society, I don't know if you're familiar with them, they do a lot of scientific research. They assumed boats going over the horizon was from refraction. But I guess now we say
they assumed it, but how would refraction make something disappear? Or let's say the sun sets.
Yeah, I can give you a demonstration from the University of Georgia. And there's YouTube videos of people mimicking this. When you introduce temperature gradients, things can merge into the ground and drop.
Sometimes
basically have a sinking effect.
Yeah, for thousands of years, the conditions are strangely enough in such a way that refraction can make things disappear over a horizontal surface.
Do you not think that's possible?
It's a real phenomenon that is scientifically already explained. That it's called sinking mirages.
I'll give you the live stream text.
Hang on. You do agree that the sun sets, yes? And then it rises again.
Are we moving from boats to sunsets now?
Yeah, I agree.
It's ties into the same thing. Sunsets and sunrises happens all the time, yes?
I want to, can we conclude the final point? Because this is another point and I can give evidence for that and stuff, but I just want to make sure we've assumed that things can appear to drop over distance or be cut off due to refraction.
It can, but how much do the conditions change during a year? Let's say, especially up or north where I live. We have warm summers, your ice cold winters. It always happens the same way on a clear day.
It's not actually the overall weather, it's the temperature gradient. And the reason the temperature gradient is there, and it's very bad on the surface, is due to the sun heating up the surface of the earth.
In the winter time, in the winter time where I live, Taylor, the sun around 21st of December, the angle above the horizon is about 4.3 degrees in the midday. So there's hardly any radiation heating up anything. And at the same time, it can be really windy. And the sun sets just as it does on a normal summer's day when the sun is high up in the sky.
I just tagged you in something. Can you look at that really quickly?
As I said, I'm out walking the dog for the time being, so I'll look into it after.
Okay, all you have to do is look at your phone notifications. And it's one picture. It's just one picture from the University of Georgia. This explains why things appear to be cut off bottom up, and it explains that type of refraction. So it doesn't matter the time of year. If you're going to be looking through a gradient, you're going to have light bending in different directions, and so that can make things appear to be gone. Like, literally, and this one I think it says vanishing point. Yeah, vanishing line, where you no longer see it because the light rays aren't hitting your eye because they're being bent in different directions due to different densities.
If you read that paper, it's not saying that light actually does that. It's saying that this is what you would see if it did do that. It does not say it doesn't.
So do you want me to give you a paper that light can move in this direction along the surface of the earth, and it's actually very common? Do you want to pay for that? Because I have one. Just let me know what you want.
Yeah, that's an example of if the air above is cooler.
Yeah, and guess what? Yeah. When you go up in elevation and you climb a mountain, what does the air become?
When in the wintertime where I live, where it's windy, there's hardly any temperature difference in the wintertime.
The general trend of the atmosphere is that it gets cooler, and it's much more profound near the surface.
Yeah, but in the wintertime where I live, where the sun is so extremely low, and by the way, it's above the horizon just for a few hours, which means that the conditions are quite stable because there's hardly any warmer when the sun is up than when the sun is down.
Have you measured the temperature gradients?
Not the temperature gradients, but the air temperature, yes.
You measure the temperature gradients? Well, let me see your data. I'd like to see it.
Do you think I keep it in my pocket?
Or just whenever you get done walking your dog?
Yeah, I need to get.
I'm happy to look at any data. That's the thing.
Yeah, but check out anything. You do realize that, like, the Midland and northern part of Norway has really cold winters.
So what? The sun still heats up the surface. It's absorbing those photons.
North of the Arctic Circle, there's no sun in the winter. Still.
Are you doing measurements there?
The moon and planets do set.
Okay, let me explain. All right, so whenever you're looking, you know about celestial refraction, right? Are you familiar?
Yes, I know.
Okay, so when you're looking straight up, there's not much refraction. However, as you start to look closer to the horizon, you're now looking through a very steep atmospheric gradient. Because near the surface, you're going to have a lot of atmosphere and a lot of messiness with humidity, temperature, and even nitrogen and stuff can affect it. The presence of certain molecules in the air. So it's going to be a very messy terrain that you're looking through. And so the light's going to be scattered. And the same effect's basically going to apply if you see right there with the palm tree, if you look at the picture.
Did you hear what I said? When you're north of the Arctic Circle in wintertime, there's no sun.
Okay, do measurements there, get the temperature gradient, and send them my way.
They do. And at times when it's calm, when it's really calm, the cold air is flowing down from mountains and float out over the ocean and the sea. So you can have quite often a situation where the coldest air is close to the ground and warmer air on top. And still the moon and the star sets at the horizon.
The only thing that's going to make a difference is you presenting data accounting for refraction.
Yes, I have to go up to north of the Arctic Circle then in the winter to do all those measurements.
Okay, well, if everybody's done them,
I spent quite a few years in the army up there. And we were quite a lot outdoors.
If you're invoking
Yes,
it, somebody's
I know what it's like. I know what it's like.
Okay, cool.
in the wintertime.
That's fine. Send it over so we can know.
So do you think that the air temperature will change a lot during the day when you don't have any sun, when you don't have
near the surface?
When you can't see the sun at all?
I don't know. I haven't seen any data measuring that in particular.
It was a simple question. I mean, it's a question that
I don't know. I don't want to invoke anything.
Yeah. What would you think?
Because we know the ground's based on the data I've seen, the ground is normally warmer than the air above it.
Yeah.
Can you calm down? Can you calm down, please?
Without the sun.
Without the sun. That's what I'm trying to address, but you keep sporadically interrupting me.
No. Do you think that
Let me know when you're finished.
Do you think the air temperature changes a hell of a lot during the day?
Okay, I was just trying to answer that. Okay, so I see that the ground is normally warmer than the air above it, based on all the data I've seen. That's all I've seen. Even during the nighttime. That was done in Kentucky during spring, and it was generally fair, cool weather. The ground still seemed to be warmer than the air above it day and nighttime. So in terms of Arctic areas during the daytime in a certain season, I'm not sure. I wouldn't know.
Well, the sea is usually a very low temperature, 4 to 6 centigrades.
Nor do I know anybody who's done measurements there.
For fuck's sake, we know this. I mean, the temperature of the water has been measured over hundreds of years. So we know what the temperature is like in the water in the wintertime. That's no surprise, and not really like up in the Barents Sea.
Cool story. Like, I believe you.
It's a cool story. Jesus Christ.
I don't know what you're talking about unless you have something to present.
Yeah, have you ever been north of the Arctic? Well, look it up then. Go up and look like the average
Why would I look up your evidence?
Svalbard in the winter.
This is you're presenting this point. You should look it up. I'm sorry, Stefan. I'm just saying, like, I'm happy to look at it. Like, I just don't know. Like, if I've never seen it, I don't know what you're talking about. You'd have to just show me. I mean, we're just speculating. But if we can see things move throughout the day, you can do a simple time lapse and see if even I've seen a time lapse on mountain ranges. They're moving too. So like, why would I assume curvature when I see things at a certain elevation? If I see also things consistently getting shorter each day, wouldn't I just assume that's a product of the changes that are happening? Like
we know refraction happens.
So it's just crazy. It's like whenever things are above, like all from your glow prediction is refraction, but whenever it matches, it's curvature, and it just seems kind of inconsistent.
So when you compare this to like GNS measurements, Dolomars, the LBI, and so on and so forth, why do they give evidence for the Earth to be spherical when you're not riddled with those kind of problems?
Don't the satellite systems already projected onto a coordinate system that matches a globe?
Yeah, but the VLBI is not. It's a ground-based system.
Do we get that raw data? And like, what about the raw data says globe?
Because the radio signal is coming in from the same source.
What is the signal that they're giving you? What are you measuring? What's the difference?
Radio signals from quasars.
Quasars now?
Yes, it's used in the ITRF. It's used for the international reference frame, both the celestial and the Earth reference frame, ITRF and ITRC, and it's extremely accurate.
Okay, present the data. I'll check it out.
Yeah, just go ahead and look up the VLBI.
This is ridiculous. You know, if flat earthers cite something, and y'all be like, "Oh, cite your sources." Y'all don't cite nothing, and they're like, "I'm like, okay, cite your source," and it's like, just look it up. That's what I get. Crazy. Isn't that crazy? It's pretty inconsistent.
Yeah, Stefan, it does take more time to get a specific source you might be referring to, but wouldn't it be best if you actually gave a source that you think is valid for it instead of just telling someone to go look it up? They might find, who knows what they're going to find, you know? If you just do a random search, you might find maybe something that's debunking it, or maybe some wrong information or partial information. So if you're going to put something forth, don't you want to provide a citation or something that actually links with something that you're referencing directly?
Yeah, to take people's word for it. I mean, y'all don't take flat earthers' word for anything. And you want them to take your word for it? Like, I have to look up, this is like, for example, like, they'll say, oh, Himawari, these are raw pictures of the Earth. I'm like, where can I get these raw images that haven't been altered? Okay, so then they give me a source. That's good. I go look into it. They actually do orthographic rectification. where they're making and stretching the image to match the coordinate system. I'm like, how is this proof of globe if they're saying they're manipulating the picture to match a globe? So it helps to have the source to go look into the materials and methods of what they're using and doing. And a lot of times with the satellites, they do, like for the y-axis, they'll go through post-processing and use the y-axis and basically go off of what they've already measured or assumed. So it's like hard to use that as evidence, and because they're already saying they're changing it.
Okay, I just posted a simple one as a start for VLBI measurements. I mean, there are thousands of scientific papers regarding it.
Are these raw measurements proving globe?
Yes, it is.
Okay, go ahead and describe
if you go to the International Association of Geodesy, there's a place there where you can actually download the raw data.
So what's the difference in this measurement method? Like, what would I expect if it was a globe versus flat? Like, what's the key difference that's being measured? You see what I mean? What would you expect in a flat versus globe, and what are we looking at in particular?
I would expect the angles of the different radio telescopes would point differently to the same source, and that the radio signals would reach each and every radio telescope at the same time. Like the radio telescope, like the radio telescope in the South Pole.
So it takes a longer time. It takes a unusually longer time.
It
takes an unusually longer time to hit the receiver. Is that what you're saying?
Yeah, the amplitude, the phase of the radio signal, combined with the time difference between the telescopes, and how those time changes as the Earth rotates, gives a good example.
So this is looking at rotation.
No. That's another thing. Rotation comes on top of it.
Okay, so let me just say, if there are, so basically the point is, the further away receivers are receiving the signal at an unusually longer time. Because it's a globe, right? Because of curvature. Is that the point?
The face of the Earth. Let's say we have let's say Honolulu is pointing, the telescope now on Hawaii is pointing straight up, 90 degrees at the source. The telescope at the South Pole and way up in Svalbard, which is not that far off the North Pole, for the same signal to reach those two takes longer. And this signal is coming from such a far away that you might look at it as a straight line coming in perpendicular to the telescope, like on Hawaii.
So the ones further away take an unusually longer time, right?
Yeah, it takes longer. It does.
Okay. So, I mean, we would expect it to take longer if it's traveling a further distance, right? We're accounting for that, right?
Yes. But then again, you have to take into account how far away this radio signal is coming, and that it's basically, it's not like a curved radio signal. It's like completely flat, coming in like a straight line perpendicular to, let's say, the example of the telescope at Hawaii, which is looking straight up.
Radar signals coming in flat.
Okay, so let me ask you, is there anything else that can affect the time of a radio signal?
Yes, the atmosphere, which is taken into account.
So we know that other factors can slow down radio signals and have the same result.
Yeah, there's done a hell of a lot of study of that, so that's corrected for.
Okay, so let me just ask, like, is the atmosphere always the same, and are we measuring the atmosphere to confirm how much they're slowed down by it?
Yes.
How do we know how much the atmosphere slows down the radio signal?
By measurements.
Okay, because I think that the atmosphere is slowing down the radio signal. Now they account for it, but it's only very minutely. And I'm
it's very minute.
Yeah. So cite those experiments where we've shot them through the atmosphere to measure precisely how long it's slowed down, and also take into account that this is a cumulative effect.
They do.
The measurements and how they account for the atmosphere, I don't think are being incorporated and accounted for. I think the atmosphere is causing the signal to slow down, and that's something that you need to measure and make sure of how much the atmosphere is slowing it, and that it's not just from curvature, because there's other things that can slow down the time.
But as I said, there's been a hell of a lot of studies how this affects the LBI measurement. I mean, there's hundreds.
The same thing with the standard refraction. Standard refraction on Earth, there's a lot of studies confirming it. Well, now there's a lot of people putting out papers that are saying standard refraction is not accurate at the same time. Do you know that?
Tayler,
So they weren't accounting for the atmosphere.
Yeah. As you said, when you look straight up, there's hardly any refraction at all. Yes.
Are they looking straight up? No, they're having to go through more atmosphere horizontally, and that's most likely, in my opinion, why the timing signals. You have a bad problem interrupting people. You never let me finish. Please, can I finish?
Right.
If they're going through at a horizontal rate, they're going to be experiencing much more atmosphere than a vertical signal. And that's the exact result that you're getting, that you're saying proves globe. You're saying the ones that are further away are having an unusually long time delay. Well, they're going through much more atmosphere at a horizontal rate. Are they accounting for these things? Because in the same way they accounted for terrestrial refraction, they weren't actually accounting for these things. And whenever I do it, I get different results.
Yeah,
I'm just saying the timing can be from other reasons.
Because it ties into the phase and the amplitude of the radio signal as well.
Okay, look, send me some data and I'll check it out.
Well, as I said, the LBI is a hell of a large.
No, on how they account for atmosphere, slowing down signals.
Okay, well, yeah, I can do that.
Not in particular is what I have in contention, because they
freezing
clearly
my
butchered
fingers
the
off there.
terrestrial refraction. Why would they not do that with the celestial? Why would I assume any different? And they've called other papers have called them out for doing this, by the way. They've said, hey, this terrestrial standard refraction is garbage. These are other scientists. But if you want me to, Stefan, I'll look a little bit more into it with the timing delays and how they actually confirmed that they're accounting for the atmosphere properly, because that's the exact result. I would personally expect there to be an unusually long time delay if it's going through more atmosphere as well. Just saying, that's what I would expect. Because if it's going through horizontally the atmosphere, same thing with the sun rays. You're looking through the sun to the sun, going through much more atmosphere, and the light can be scattered. And the radio waves are also really affected by humidity in particular. You're going to be going through a lot more humidity.
Just a quick look up. I posted 2 links regarding VLBI. One is an example of correction of atmospheric conditions.
I don't doubt that. I just need to know that they're accounting for the atmosphere, right?
That's what I just said. I just posted a link
this is an
to
atmosphere?
how they do correct for atmospheric conditions.
What did they test?
I can't read it just now. By the way, I need to stop because I have to put my gloves on. My hands are fucking freezing.
No, you're fine, Stefan. Keep walking your dog. We can continue this later. Yeah, thank you for putting it forth. I actually did want to look into that a little bit. I know everything I said was correct, but I don't know how they, how many measurements have they done shooting radio waves through atmosphere to see the cumulative effect at a horizontal angle? I'm not sure. I would assume they did the same thing with the standard refraction and just took a general gradient and then put it in there, but not accounting for the fact that there's a lot. I don't know. They just didn't account for everything. The vertical temperature gradient near the surface is much different than the upper atmosphere, and they applied the upper atmosphere to the lower atmosphere, and it just doesn't work. It's not equivalent. But thank you for sharing, Stefan. I really appreciate the combo. I'm gonna go to bed soon, so if anybody had any other questions. Yeah, I think it's a little harder than you think to just say, okay, let's just go prove a globe for ourselves. Like that's kind of what I set out to do, and it's been a little bit more difficult than I would have expected. Well, if you don't account for things, it can seem simple because you can make assumptions. But when you in research, what you do is you account for any variable that can cause that same effect. So what can cause radio waves to slow down and what can cause things to appear to drop over distance is, refraction. And so in research, you'd have to properly account for those things and measure them. You can't just assume a standard. You can't do that. You have to measure, especially if you're going to use the results to make a conclusion. We're determining the cause here. Is the cause of the delayed radio signal due to curvature, or is it due to refraction, another variable that can cause the same effect? You'd have to properly account for those variables. You couldn't assume what they are and, the impact of them. You'd have to test it.
Yeah, and as I've said, I just linked 3 examples. I mean, how they do these things. They even use satellites to see how water vapor and stuff like that. Refraction is
But if they assume curvature, but what if they're also assuming curvature whenever they're seeing the time delay? And then how would we know if the time delay is from curvature or from atmosphere if they're assuming curve?
Assuming? No, they're measuring they're measuring the delay of the radio signals. There's no assumption there. That's what they do.
Okay, so they're not saying curvature is causing a delay. They're just primarily testing atmosphere.
As I said, Tayler, I just showed you 3 simple examples of how. And this is just like one.
That was a deflection from my simple question. That was straightforward.
Yeah, I was trying to explain to you. These 3 examples of thousands scientific papers regarding how the atmosphere affects radio signals when they do VLBI measurements, different ways of testing this, and so on and so forth.
My question stands: that are they assuming curvature when they're looking at the timing delay and attributing it to that? Because then, whenever they do the compensation models to get the standard refraction of the atmosphere for radio wave signals and satellites, then they would already assume that and bake it in. So then, therefore, you couldn't use that to differentiate flat or globe. You understand?
No, Tayler. When they do these measurements of the effects of the atmosphere, the curvature of the Earth is played into it.
It's played into it. That's the problem. That's precisely the issue I'm raising.
They like different angles. I mean, where like they use even satellites. So you have it straight above you. It drops. It moves across the sky, and the angle changes.
I'm looking at your papers right now.
So
you said they're in the live stream, right? Yep, I see.
Yeah, in fact, just 3 simple.
Is it the one at 232?
Hang on, I have to go back.
Yeah, I think it is. I think this is it because the title matches the topic. So yeah, I appreciate you for sending me this paper, Stefan. Not many people send me papers, but I always love reading them.
Yeah, and I mean, the problem is, like, if you go like to Google Scholar and you start searching up these subjects, it's like you're finding thousands of.
I know. That's how I know about this problem.
Yeah, and why?
How would I know about it otherwise?
The biggest problem is which one do you choose to put forward? I think that's one of the biggest
You don't discriminate. Anybody who's actually tested it, the results speak for themselves.
They
But
do.
see, the only issue would be is if they're already assuming curvature and then using that to compensate to make their standard diffraction model for, radio waves in the atmosphere, then how would we differentiate between globe and flat if it's already baked in there? You see what I mean? You couldn't use that.
But they hardly ever take the curvature of the Earth into account. What they tend to do mostly when they do these, as far as I've seen, is it's basically the direct line of sight, if you want to call that, radio signal line of sight from the satellite to the ground station, and how that varies as it moves across the sky.
Mm-hmm. Well, I hope that what you're saying is true, but I'm looking into it now. I'm actually reading into your paper at the moment, so you can keep walking your dogs to find.
Those are just examples.
Okay, yeah. Thank you for giving me some.
It might not be the correct one for what we were talking about. Yeah.
Okay, so they're evaluating the accuracy of these methods for correcting for atmosphere effect. Zenith wet delay measurements. I wonder what compensation method they used in the satellite data that you put forth. I'll have to look into that. Anyway, if anybody else has something to share, by any means. And in this paper right here, it also mentions that the atmospheric wet delay represents one of the major error sources for space geodetic observations at radio wavelength. So what I put forth as an issue, this paper is agreeing with.
That was the point. They are aware and they do study this to compensate for it.
But you know what I've seen in the scientific community? That a lot of people do study these things and they put forth issues. Now the real problem is do people actually compensate for them? Because there's been a bunch of papers I found like exposing standard diffraction. And then when people come on here with their surveying data, they use standard diffraction. They don't actually account for the atmosphere as the papers say they do. This happens in the medical field too. The scientists will raise many issues. Hey, this is toxic. We probably shouldn't use this. Here's some cool, remedies that could be useful for this particular illness. But guess what? Nothing happens about it. People raise issues all the time in the scientific community. Getting something actually done about it is like a whole nother issue.
But have you looked into how much studies which has been done, like when it comes to celestial refraction, that being light and radio signals and so on?
Yeah, and some of them are wishy-washy. So, Stefan, can you tell me what the GPS data was again? What's the name of the one that you brought forth, like the particular one? You said the blank has studied this heavily. What was the one? The exact satellite that you brought out?
The exact satellite?
Or what was the method that you brought forth that measures curvature? You said GNS. Do you have a particular one?
Oh, VLBI.
VLBI? Okay, thank you. That's all I was going to.
Yeah, because I find it strange that all of, everyone working within, the International Association of Geodesy are so completely wrong when it comes to the shape of the Earth.
I mean, it's just like I don't think that's the only people that are saying that this time delay is like they compensate for a time delay. Now the question is the time delay due to curvature or is it due to refraction? So we're they're compensating for it, but we're deliberating something else. So I'm not saying the scientific community isn't aware of the what's the effect and are they compensating? It's like what is the cause of it? That's what we're deliberating, and so that's less important. As long as they're correcting for it properly, that's for the most part all they need to do is make sure they're accounting for it, correcting for it. Now what's the cause of it? It's a whole nother ballpark.
Yeah, but that's the whole point.
Just one question, Stephen. Taylor, you repeated that multiple times now, that refraction causes time delay. Can you explain that?
Yeah, so radio signals are heavily affected by things like humidity in particular. And so humidity will slow down radio signals or, it'll affect radio wave propagation and cause timing delays.
You're now talking about density and humidity. You specifically mentioned 3 times at least that I heard of that refraction causes time delay. How does refraction cause time delay?
How does refraction cause time delay? Because it's like radio waves also experience refraction, but it's just humidity. Like, so water, like the, the wavelength that we're working with, like talking about visible light, that's heavily affected by temperature. Now different wavelengths, like radio waves, they're going to be affected by different things. So radio waves in particular are affected by humidity, whereas visible light's affected by, certain things will affect different wavelengths differently.
Yeah, radio waves are dampened by humidity. I'm pretty sure they're not slowed down by humidity. They can be slowed down by higher density, where the refractive index is higher, but the time delay, refraction has nothing to do with the time delay, other than the light path may be a different one. But you're claiming refraction causes time delay, and that's not true. Refraction takes another path, or causes the radio signals to take another path.
But if they're taking a longer path because it's being scattered, wouldn't that cause a time delay?
No, actually, they're not taking a longer path. That's the whole thing on refraction. Refraction, the light path that is caused by refraction, is the shortest time possible.
So water vapor increases the atmospheric refractive index, causing radio waves to travel more slowly than they would in a dry air vacuum. It's particularly significant for geodetic techniques like GPS, VLBI, and satellite communications.
Yet you are constantly interrupting. I was responding to you, and you directly interrupted
You can
me.
calm down,
You are
sir.
the one
Like,
who are
please.
always claiming not to be interrupted, and you are the
Not
most one
really.
who's interrupting. So can I now continue
You're
with
like
my point
freaking out,
about
bro.
time
Calm
delay
down.
and reflection, Taylor?
Sir, can you calm down before proceeding?
Okay, I'm super calm if
Okay,
I'm
you
not
can make your
interrupted,
point.
but you
I
are
was trying
always
to read
claiming not
something
to
that
be
clears up the
interrupted.
thing.
Yeah,
Okay,
in the
this is
middle of my
meta. I'm
sentence.
trying to go to bed. Can you make your point swiftly?
Yeah, sure.
I've
If you're
already
not
announced that I'm going to
interrupting,
bed before you
okay,
started
then please
talking.
shut up, then I will continue. Okay. Refraction and the index of refraction is caused by the shortest time radio waves or electromagnetic waves take. So a direct path through different density mediums will be longer than the refracted path. So a time delay is not caused by refraction.
Okay, so there is refraction and absorption. So the water vapor increases the atmosphere refractive index, causing radio waves to travel more slowly than they would in dry air or vacuum. There's also the slowing effect. It's a form of refraction where the changing refractive index bends and delays the radio signal. Humidity also causes absorption and scattering of radio waves, particularly at higher frequencies, and near water vapor resonance lines around 22 gigahertz and 183 gigahertz. Okay, does that make sense? Does that clear up the thing?
No, what are you citing there?
Yeah, I can send you this link that explains it.
Because do you agree that moist air is less dense than dry air?
Yes.
So how does it cause the light to travel slower if it's less dense?
Are you talking about visible light?
We're talking about electromagnetic waves.
Okay, are you talking about visible light or radio waves?
Does it matter?
You need to make your question a little bit more specific. What are you trying to ask me?
So you know that higher moisture in air causes the density of air to be lower. Lower density causes light to travel faster, electromagnetic waves to travel faster. Correct? But in the paper or in whatever you cited there, it said that it causes light to slow down. How does that work out?
So water molecules have a permanent electric dipole moment that can align with the oscillating electric fields of radio waves. The lower frequencies of radio waves compared to visible light allow water molecules sufficient time to respond and align with the changing electromagnetic field, which increases the refractive index and causes signal delay. At optical frequencies, the oscillations are too rapid for the water molecules' dipole moments to follow, so this alignment effect is minimal.
At which frequencies is it affected?
Radio waves. So
radio is not a
let's
frequency.
see, radio waves bend more than light. Okay, so this is another thing. Let's read it. The effectiveness of water vapor's interaction with radio waves depends on the temperature, since thermal agnation particularly disrupts the alignment of dipole moments. At higher temperatures, random thermal motion reduces the degree of molecular alignment, while cooler conditions allow better alignment and stronger refractive effects. This temperature dependence is less significant for visible light, which doesn't rely on molecular dipole alignment for its propagation characteristics. So we're getting some technicals, but to make a long story short, radio waves are slowed down by humidity.
And your claim that refraction causes that is now...
Yeah, I mean, it's related to refraction. I read that earlier.
The thing is, atmosphere conditions...
Seems a bit more nuanced than like a simple... But yes, the answer is yes, refraction. Humidity slows down radio waves, and this effect is related to refraction.
No, refraction is not causing light to slow down, Taylor. Atmospheric conditions, density of the atmosphere, moisture in the atmosphere slows down light. That is true. And slows also down radio waves, but not refraction slows down. Refraction is an effect. And the slowing down of light or of radio waves causes refraction. It's the complete other way around. The slowing down of light causes refraction, not refraction slows down light. You have it completely misunderstood the wrong way around.
You're repeating yourself. Either way, radio waves are slowed down by humidity, but we're getting in nuances, which is fine. But let me just read this. Refraction does slow down radio waves, though it's more accurate to say that the medium causing refraction slows down the waves. Does that make you happier?
And you're citing some AI or bullshit. Refraction...
Then prove me wrong.
Because I just explained it. Refraction is an effect that is caused by slowing down.
This is totally irrelevant to the actual point at hand.
The actual point at hand is that you don't understand the physics and still you're arguing about it.
Can you prove me wrong that humidity slows down radio propagation? Because that's the only point I made.
No, you made the point that refraction slows it down. And that just proves that you have it backwards. I just wanted to point out
what I'm reading says that, so if you have something else, then cite it.
Because you have it backwards.
If you have something that disagrees with what I said, send me a link and I'll check it out. But the point stands. The whole thing stands. The whole argument was defined.
Yeah.
Completely stands. Whether you want to call it atmosphere, whether you want to call it refraction or not, like, it's a very technical thing, like how humidity affects radio waves more than light waves. Either way, humidity slows down radio propagation. That was the only point I was making. You get into the water dipole moment. I mean, that's pretty crazy. Can you explain it? Stefan? Or sorry, what was that last
What,
Snooze?
what
Can you
explaining?
explain why humidity affects radio waves more than light waves?
Oh yeah, because lower frequencies are causing oscillation in the water molecules. That's correct.
That's what I just read, but why?
That's also why water is dampening radio waves, because it's absorbing the energy of those. That's why you can, for example, use microwave to heat up water. But the thing is that I was pointing out is that you repeatedly said refraction causes light to slow down, which is just blatantly wrong.
Humidity changes the refractive index, which determines how fast the radio waves travel through it. I can cite that.
Yes, Taylor, maybe open your ears.
So my statement wasn't incorrect.
It's incorrect. Open your ears for a second.
What part
I repeat it one more time. Humidity causes light to slow down, therefore causes the refractive index to change, therefore refraction happens. So the refraction is the end effect of the very initial effect that light slows down or radio wave slows down. So the refraction is the effect and the slowing down is the cause. And you claimed that refraction is the cause for light slowing down. That is, if I said,
did I really say that?
A wet street causes rain. That is wrong. Rain causes the wet street.
So humidity changes the refractive index, and that will determine how fast the radio waves travel through it. So if I say like radio waves are affected by humidity.
No, Taylor. The speed that the radio waves
I'm just
through
reading
a medium.
scholarly sources right now, so I don't know.
I don't know. Then these sources are wrong. The speed that a signal.
Send me your sources, however you want to word it. The whole point stands. Everything I said, like about humidity slowing down radio, all that's correct. You're just mad about how I said it. Kind of weird.
I just wanted to ask you if you understand it.
Do you have a point that actually is related to the conversation or the debate topic, or are you just trying to debate nuanced terminology and verbiage? Is that all?
I'm fine. If you say, okay, you had it backwards, I'm fine. The thing is, these are very minute, changes, and you're always arguing.
What I'm reading is kind of wording it how I said it, but if you think I worded it wrong way, like you can have it.
You are again interrupting me, right? Just to point that out.
I'm just trying to finish what I was saying, and I'm trying to go to bed. I'm trying to give you some leverage or whatever, give you a point. So just chill. I said, okay, if you say I'm, you agree with the premise and the whole point of the statement, but if you think I should have said it a different way, or my terminology was wrong, fine.
I agree with the premise. I agree with the premise that light can be slowed down by different density or by different humidity in air, but this is a minute effect compared to distance.
Okay, we're talking about radio waves, which heavily is affected by humidity.
So, for example, I bet if you are impossible to, for example, slow down the light by the half of the speed, but if you just double the distance, you have double the time. So the slowing down of the speed due to density or humidity is a very minute thing. And if you don't account for it, you just take the maxima and wait a second, you're interrupting again. You just take the maxima and the minima, and then you have your error margin. And everything in between the maxima and the minima, you can, for example, see as the same value. And then you can calculate the differences. So when you always claim, they just
come on, bro, I'm trying to go to bed. Seriously, don't do this. I'm just gonna have to leave. I can't do this. I'm literally sitting here waiting to go to bed. Please just summarize your point, Stefan. Is that possible? This isn't even relevant.
Okay. Go ahead, Taylor. Interrupt. Stefan can continue. No, Stefan is actually not here anymore. Good night, Taylor. Sleep well.
Okay.
Well, you were kind of monologuing and linking a bunch of points together, so.
And I'm he knows I'm trying to go to bed. Okay, yes, Snooze, you're right. Maybe I should have worded it different. Okay. Thank you for pointing that out. Are we good?
Good night.
Okay, you too.
I mean, I wasn't saying you were completely monologuing, but it was just it sounded like you were finished on a point and then you just started up a new one. That's all. I wasn't saying it was egregious, but.
Yeah, that's fine. She wanted to go sleep. It's fine. And I agree with her that you can get more accurate measurements if you account for the actual refractive index, so the actual density on the medium and so on. But if you're not accounting for the very current refractive index of all these separate points, you can still take the error margin as an average. And you can say, okay, plus minus, I don't know, let's say even 1 degree or so. Plus minus 1 degree would be an absolute maximum. And then you account for this error. And that is what is used with standard refraction. It has just a bigger error than the actual refractive index. And you can still use these values.